Thank you. Well, welcome all. I'm going to start off with the presentation that myself, Jason, and David, who is on the Zoom in California or Nevada. So basically, we looked at the initiative that represents a significant movement towards achieving a sustainable future that aims to substantially lower carbon emissions, improve efficiency and resiliency, and decrease overall energy consumption, all while enhancing building performance. By collaborating with the industry professionals, we have identified essential financial investments and developed a comprehensive cost estimates, setting the stage for transformative changes in our approach to sustainability. So beyond financial benefits, renewable energy systems enhance energy security by providing power during outages and extreme weather events, which is a vital feature for an urban campus like CCNY. Sustainability initiatives also transform the campus into a living laboratories, offering hands-on opportunities for students, faculty, and researchers to engage with cutting-edge technologies and systems. These efforts support CCNY mission to foster interdisciplinary learning and prepare future leaders to tackle sustainability challenges. By engaging with local stakeholders, students, and faculty, CCNY can foster a culture of environmental responsibility and innovation. These achievements, when showcased, can serve as a scalable model for other institutions. That's all right. So the current North Academic Center energy usage is approximately, index intensity is approximately at 313.7 kilobtus per square foot per year, substantially exceeding the US median for educational buildings, which is 84 kilobtus per square foot per year. This discrepancy underscores the inefficiency of the NAC's current energy system, highlighting the need for targeted measures to reduce energy consumption and emission. So currently on the chart, it's the chart represents the EUIs, energy use intensities, that NAC emits, and it's at approximately 17,323 metric tons of carbon dioxide emitted annually, which far exceeds the 2024 Local Law 97 threshold of 5,270 metric tons of carbon dioxide emitted. So and this will only increase, this gap will only increase by 2030, will exceed stricter 2030 thresholds levels of 2,945 metric metric tons of carbon dioxide emitted. This will result in potential penalties under the Local Law 97 unless significant reductions are achieved. And we see here the electricity usage is pretty high, but substantially lower than natural gas usage, which transfers to high energy bill cost. So when we looked at the design and selection of energy conservation measures, we looked at the principles that were originated by our own Professor Hillary Brown in her book, Next Generation Infrastructures. These principles are support mixed land use, reduce energy emissions, inclusion of green infrastructure, social and economic benefits, and climate adaptation measures. We also began by evaluating the market landscape, which involved identifying relevant technologies and solutions that could potentially meet our needs. Then we assessed various measures based on specific criteria and pinpointed areas where interactively could enhance our approach. Then we developed a comprehensive set of synergistic measures designed to achieve our established goals or come as close as possible. Following that, we conducted a viability check to assess the complexity, market availability, and constructability of the proposed measures. Lastly, we performed a detailed analysis of energy consumption, water use, greenhouse gas emissions, and costs associated with the elected measures to ensure their sustainability and feasibility. So measure types we propose to ensure compliance with regulatory standards and state and city executive orders. We strongly recommend integrating some of the following measures, which can be independently integrated or synergetically integrated into the existing energy master plan. One of them is energy conservation measure, ECMs. They are strategic capital investments made in building system which reduce energy consumption and enhance efficiency within a building or a facility. One of those is green roofs, which represented an innovative approach to building design that involves layering vegetation and soil on rooftops. This natural system not only improves the insulation of the building, but also fosters sustainable urban development by integrating nature into architectural structures. This practice enhances biodiversity, reduces urban heat, and helps manage stormwater, making it a valuable solution for modern cities. Photovoltaic or PV and thermal technologies can also be effectively combined to enhance the capture of solar energy. One notable approach is cooling PV panels with thermal collectors, which not only improve the electrical efficiency of the panels, but 5 to 10%, but also utilize the heat that would otherwise be wasted. Another approach is wastewater heat recovery system. It's designed to capture and reuse thermal energy from facilities' wastewater in order to provide heating for domestic hot water. This innovative approach not only enhances energy efficiency, but also reduces overall water heating cost by utilizing the energy otherwise to be wasted. And the last one is the thermal storage and boiler economizer, often referred to as a heat battery. It is an innovative and compact solution designed to optimize thermal energy. This technology significantly improves the efficiency of hot water heating system. It allows for seamless integration with a variety of energy sources, including solar, photovoltaic systems, heat pumps, and electric heating system, making it versatile and a choice of enhancing energy efficiency. Another measure is distributed and renewable measure, which refers to a set of strategies designed to achieve meaningful and lasting reductions of carbon emissions. These measures focus on implementing transformative changes that include the integration of renewable energy resources, essential for meeting rigorous carbon reduction targets and promoting long-lasting sustainability. Key examples of DRMs, which is include the installation of roof-mounted photovoltaics, the use of biodigesters, the deployment of linear generators, and incorporation of battery energy storage systems. These technologies collectively contribute to a more sustainable energy landscape by harvesting renewable sources and improving energy efficiency. Another measure is operation and maintenance measure. It's a strategy that aimed at improving the efficiency of existing building systems without significant capital investment. Notable examples of OMMs include rainwater capture, organics processing, an alternative to carting waste, establishing community cooling centers, and implementing vehicle to battery storage systems. These initiatives are specifically crafted to elevate energy efficiency, cut down on waste, and optimize system performances while also reducing water consumption and enhance resiliency. By embracing these measures, CCNY can not only fulfill the government mandates, but also champion sustainability and cost effectiveness in ultimately serving the well-being of both our academic community and greater public. Although implementing these measures involves considerable capital investment, they're vital for ensuring compliance and significantly boosting the overall performance of the building. Investing now can lead to long-term benefits and greater efficiency. On that note, I'm going to leave it off to Jason.
Thanks,
to
Maria.
present.
Hi, everyone. So I'm here to talk a little bit about and get into the details on the ECMs, renewable energy measures, the DRMs, and the OMMs. And so the way that we approached once we selected our measures, we wanted to dive in and see what the annual savings would be like. Using calculators that were developed specifically for this exercise that are 8760 calculators. That basically means that we modeled the energy use for the building and established a baseline, and then a proposed condition, took the difference hour by hour, 8,760 times, to create a very precise measurement of the impact of these measures. And you can see here what those impacts are. In order to get the estimated project costs, we worked with actual private sector partners for real technology parts and pieces to get a realistic sense of what the projected costs would be. So these are very, very refined measures. And you can see the payback, which is simple payback, is a very good way to analyze the strength of the measure. And so you could see things like install green roof with a 42-year payback don't exactly look lucrative. Same with PV waste heat recovery, sanitary waste heat recovery, domestic hot water electrification with thermal storage and boiler economizer, 35% energy consumption reduction, and heating system electrification. Now, the last two measures were not specific, but we wanted to demonstrate what a potential measure would or should look like beyond what we're suggesting. So when we see 35% energy consumption reduction, this will be made clear as the consumption of the building starts to decrease. We're going to have to do something beyond just these standard measures. So the 35% energy consumption reduction could come in the form of pump and fan motor replacements. It could come in the form of DCV, measures that we didn't quite take the time to analyze, but we know they're there. So this would be a good look. The next is the distributed renewables measures. And so you see here, these aren't necessarily savings. They're generating electricity and natural gas, and then they're shifting that consumption to these systems. So these are really interesting, and you'll see really good paybacks here. So 3 of our top measures are actually distributed renewables. So install roof mounted photovoltaics has a payback of about 6 years. And compare that to install the biodigester, which a biodigester is essentially a way of capturing energy from organics and renewables and generating renewable gas, which is fed into a linear generator, which is our third measure. That has a 1.92 payback because the cost of gas, which it uses to generate renewable electricity, is so much lower than the cost of electricity. It's what's called a spark spread. So we're going to use our linear generator, which is a non-combustion technology. This is a really cool technology that essentially allows us to use natural gas in a non-combustion chamber that will generate clean electricity with a minuscule amount of the carbon monoxide or carbon dioxide emissions equivalent. So NOx and SOx, basically, nitrous oxide, sulfur oxide, way, way lower. That linear generator feeds into a battery energy storage system. So for our battery energy storage system, we did about, I think it's $1,000 per kW, and we assumed 200 kW to match up a little bit with the generator, which is a 250 kW generator. So you can see, as Maria referred to, all of these measures are feeding into one another. And you'll see the synergistic impacts on our final slides when David talks about it. Rainwater capture, these are some of the estimated project costs and the GHG reduction. So you'll see a high GHG reduction for rainwater capture, which I think might be off. But essentially, these are measures, the O&M measures are measures that may not have a payback. There might not be a quote energy savings associated with them that's quantifiable, but we know that they're important and they're a part of the operations and maintenance changes that will come with installing these new technologies. And so we put rainwater capture, organics on-site processing versus carting. This is essentially a organics collection process. The annual cost savings are versus carting. So what we did was we looked up the cost of carting a ton of waste off campus, and then using a campus waste survey, calculated that the savings are going to be, they're minimal, but they're there. So these are all good stuff. Community cooling center is shifting. So instead of having all our window shakers, which are these, distributed cooling centers, having a dedicated system for a cooling center that is a high efficiency system can yield a lot of savings, consolidating students instead of having everybody across campus, consolidating students into a set of classrooms with a high efficiency system can yield savings, and we can see that there as well. And then the last one is the vehicle to battery storage, which is different than battery storage. The vehicle to battery storage is a way of charging your fleet vehicles during peak periods without tapping into the grid electricity. So storing your electricity and then using it for, say, a truck charger during peak periods can really shift loads. Now, there aren't any calculated savings for that one, but we do know that it will result in savings energy. It's energy savings. All these measures are realistic. They're all out there. The technology is available. It's ready to be implemented. So we're really excited about that. And so before we get going, does anyone remember the EUI for that we had? It was like 300 something. It's like 3 times what the energy density should be. After we implemented all these measures, does anyone want to guess what the EUI would be? 3 guesses. Anybody? Smaller, yes. 100? Close. Anybody else? Another one? Very low. It's about half. So we calculated it to be about 248. So even with all these measures implemented, we're still experiencing extremely high EUI. Now, why is that? That could be because this is a networked building. So they're using the NAC as a centralized hub, basically, to generate heat and hot water and cold water throughout the campus. So the EUI for the NAC might be misrepresentative of the true EUI. So when we're implementing all these measures, normally we would probably see this drop to 84.3 or somewhere thereabouts or even lower. But because of the NAC's position in the campus heating and cooling loops, we have less of, or the impact is going to be a little less than we would normally see. And so we can see here the GHG emissions coming from electricity, natural gas, and the local law 97 limit associated with those emissions. And unlike Maria's slide, we'll see these emissions reduce generally over time. The green is the electricity, gray is natural gas, the orange line is the local law 97 limit, or what it would be. You'll also notice the electricity consumption, and this is 2035. So we gave the school till 2035 to implement all our measures. And you'll see the reason for that when we go into our net present value, which David's going to get into. But essentially what we see with the electricity consumption is it's way up beyond what it normally would be. And that's a result of the heating electrification. So this is another reason why you want to install on-site renewables, is because when we do scale up to capture heating systems, we're going to need that extra capacity to be able to actually generate the power needed without going through expensive service upgrades that take a long time. So the distributed and renewables are a really important part of that. And this is what it looks like. This is our grid. So these are the sustainable circular microloops that is sustainable microgrid concept design that we're talking about. You can see the agrivoltaics, the biogas digester feeding linear generator, feeding the battery energy storage, connected to the NYPA utility, going to EV charging, to network buildings. So we have all the components here on campus to make these decarbonization plans a reality. The technology's there, and this is essentially what it would look like. Now, of course, we have to do, we have to get into the weeds on it to make sure that we can actually implement this all and that it works this way. But this is a roadmap for how we can start looking at the implementation of measures as opposed to separate measures, looking at their synergistic and interactive effects. And so our top three measures, as I alluded to earlier, install linear generator, battery storage, and roof-mounted voltaics. These had the best payback. And then I wanted to highlight the mainspring linear generator in particular. So this is a 250 kW generator with you can see here, there's magnets around the bearings. The combustion chamber is in the center. It's a combustion chamber. It's a non-combustion chamber. So there's a chemical reaction that's happening that's forcing the generator to go back and forth on its air bearings, by the way, less maintenance. And essentially it's like turning two diesel pistons on their side. The air compression ratio changes automatically. So this is a fuel flexible solution. So essentially what that means is if we want to incorporate hydrogen, if we want to incorporate ammonia, biogas, whatever we want, it will automatically adjust its compression ratio to adapt to that source energy and produce electrical energy at about 45% efficiency, which is way higher than the grid. So this is an amazing product. It's right out of Menlo Park. A couple PhDs from Stanford created it. Bill Gates is now an investor. So you're going to see more. The Mainspring is one of, I think, two solution providers that actually use these. So this is going to be, I think, a big type of solution in the future. Again, a fuel flexible, renewable electricity generator that can work and be integrated with a lot of source production technologies like a biogas digester or a hydrogen digester. What's missing from our measures, before I turn it over to David, basically we doing our market evaluation, we found that there were certain technologies that weren't ready for prime time. Wind turbines, carbon capture, hydrogen. We looked at electrolyzers. The electrolyzers just aren't there yet. So the process of creating distilled water to feed an electrolyzer that's really not market available is a reason that you won't see that measure. And similarly with carbon capture, it's just not quite there yet where we want it to be a really effective measure. And the local law 97 penalties, frankly, aren't high enough. So with that, and to look at some future projections and net present values, I'm going to turn it over to David.
Hi, good morning, everybody. Can everybody hear me okay?
Yes.
Perfect. Okay, so our team understands the importance of saving the best and most exciting stuff for last, which is why I'm here to close this out by talking about capital budgeting and local law compliance and things like that. Just some quick background. As most of you probably know, CCNY is part of the CUNY City University of New York system. Every year annually, CUNY as a whole system issues a 5-year capital budget plan, which is a pretty detailed document. If you're interested kind of in the buildings and the maintenance and the things that are going on to kind of keep the schools up and running and like new projects and ideas that are envisioned, it's worth a look. But essentially, this is like a 5-year plan for capital spending. So again, mostly new buildings and maintenance that details how money is going to be spent across the system. In the most recent one, the total capital budget for 5 years for CUNY was 5.44 billion. 4.2 billion of that was for senior professional graduate schools. 1.24 billion was for community colleges. Again, if you don't know a little bit about CUNY, by and large, the community colleges are city funded. The senior professional and grad schools are state funded. That distinction is not absolute. There's some bleed through, but just by and large, they're done that way. And obviously the senior professional grad schools tend to be like a little larger and the buildings are a little more intense and everything else. So usually that capital budget's higher. Priority areas of the most recent capital budget, you can see there's this capital renewal initiative to bring the CUNY campuses to a state of good repair. That's going to come up a little bit with CCNY, the completion of active and ongoing work. Technology projects and the fourth one, projects to meet energy conservation, both have some relevance to the sustainability work that we're talking about. And then obviously strategic initiatives for new construction of space or just sort of new buildings. The top one is a good repair is a pretty significant issue for CUNY system wide. There's just in general a desire to bring a lot of the older buildings up to a better state, do repairs that have been needed and put out, things like that. Next slide, please. Okay, so CUNY sustainability, they within the capital budget plan talk about energy conservation and the Build Smart programs. This is like a part, it's not the entirety, but this is a significant part of the overall system sustainability goals. I'm bringing all this up kind of as context. You can see that against a $5.44 billion total capital budget for 5 years, you're talking about 5.5 million year one, 1.7 million year two. These are programs that just aren't that well funded in the overall grand scheme of things. And that's again just kind of background to let you know, like there are things like new construction and state of good repair, bringing buildings again, modernizing them and everything that are a little bit higher priority, which isn't necessarily what we want, but it's relevant for the funding of the overall project. Next slide, please. Okay, and then CCNY specifically, this is also from the 5-year capital plan document, 27 million total, and that's for over 5 years. All of that is classified as asset preservation. I mentioned the state of good repair. So CCNY, obviously, you all know the buildings in certain cases are a little older. They're not maybe 100% of the time maintained as well as they might be. And so at the moment, the capital plan is pretty much all spent on asset preservation, which from our perspective is an opportunity for some money that could be sort of redirected towards sustainability. You'll see the planned projects on the right. There's just some basic site infrastructure improvements, upgrades. That second bullet point is somewhat related to sustainability. BMS, building management systems, will like make the building slightly more energy efficient. Envelope and interior upgrades, Marshak and NAC improvements, things like that. But this is all kind of state of good repair focused. Next slide, please. Okay, so the way that we did our 30-year baseline was we got data from CCNY directly for the years 2020 to 2023, electric use, demand, costs, natural gas use, natural gas cost. We calculated this out by month and basically came up with an average. The idea being that the NAC is a mature building. It's not, its energy usage ideally is going to go down as it becomes more efficient and some sustainability measures are put in. But it's not likely to have like huge energy increases because it's been there for a while and it's pretty much used nearly capacity or in that general range. So we kind of use that and these years as an energy baseline. And then we did a rate calculation to project out cost over 30 years, calculating, adjusting for inflation and all of that. Next slide, please. And I think, yeah, this is the one with the big table. So you can see here, I'm going to read through every individual number just to make sure you guys see them all. But I don't have to probably because we're a little short on time. Okay, so we do have substantial costs with or without local law 97 penalties associated with not moving to sustainability. As Jason and Maria both talked about, there are, reasons beyond cost to do that. Everybody in this room understands that. I mean, greenhouse gas reduction and kind of more efficient, sustainable systems are important, regardless if they were going to cost more money. It would still be a good thing to do. But there's also this financial aspect in terms of local law 97, and just the increasing cost of energy, which incidentally is difficult to forecast. These are all based on no significant spikes in energy costs, due to world geopolitical events or all kinds of things that may or may not happen. We're just assuming that energy costs are relatively static other than inflation, which is far from guaranteed. Next slide, please. And then here we have the proposed measures, the reduction. You'll see significant savings, net present value cost, and 20 million less than the business as usual case. Local law 97 penalty costs reduced by around 10 million. You'll have to do, the shift to electricity carries additional burden, and the on-site generation will be essential. Yeah, this is, and as that last bullet points out, this is sort of the beginning of a plan based on current technology. All of this obviously could and should be improved. And that can be done, there is, as we saw in the original couple slides of the capital plan, funding for this, right? Funding the initial outlay with sustainability measures is always the question. It's cheaper to just continue buying gas and electric than to invest upfront capital dollars, or it feels cheaper, that is, to invest upfront capital money in new systems. But over time, you can kind of see how it ends up evening out, and that's just on the money side. Obviously, not really dealing with the importance of sustainability more generally. Next slide, please. Okay, and then we have a couple funding opportunities. There's a table within our final report that contains both some federal grants, that's from grants.gov, 13 opportunities ranging widely from 2.5 to 30 million. These didn't tend to be really directly applicable, in the sense of, unfortunately, there weren't a lot of grants for, like, we want to buy public colleges in New York City, photovoltaic systems or anything. But there are a lot of them that have this sort of general, investigation ideas, hiring temporary employees to do studies and analysis and things like that. And these could sort of be used as springboards for the platform, or for some of the measures that we're suggesting. Next slide, please. Oh, oh, okay. Sorry, I got a message from. Can everybody still hear me? Okay.
Yes.
Okay, sorry, there was a message that somebody couldn't hear, but okay. And then finally, NYSERDA, 7 opportunities. Again, obviously from New York rather than the federal government. Similar ideas around doing studies and kind of working in concert, public-private partnerships, things along that nature. Not maybe directly applicable, but things that could kind of be used to offset or defray costs. A smaller number of opportunities for smaller dollars, but things that could be helpful. And then next slide. Okay, that's it. Thanks everybody very much. Thanks for thanks for allowing me to zoom in to the meeting. And any questions?
Hello, my name is Joshua Young. This is my team, Gabrielle Perez and Kevin Kim. And we are here to talk about assessing the impact of wildfires on coastal water quality in California.
Yeah, just put this on. She doesn't. Oh.
Oh, okay.
Okay, and part of the purpose of the report, we've got a couple of questions that we want to answer. So obviously, as we mentioned at the beginning, what effects do the wildfires have on coastal water quality? Okay. And so then also addressing how can in situ data and satellite imagery be used in tandem to tell a story?
We tried it.
We're just.
I'm trying. Oh, okay. So why is this important? Warmer temperatures, as part of climate change, there's also less consistent precipitation and more, an earlier snow melt. So many areas around the world get their water through the melting of snow, and in a warmer environment. That means that there's less water availability during the dry season when most of these fires are occurring. So the wildlife-urban interface. As urban sprawl happens, more and more cities are connected to and in very close proximity to woodland areas and areas where there's a lot of fuel for fires. This is compounded with changes in forestry management. California is just starting to get back to the way they did things a long time ago, but for many, many years, the Forestry Service had a 10 a.m. policy, meaning they wanted every fire to be out by 10 a.m. the next morning. This sounds like it's good because less is burning, but it allows for more and more material to build up, leading to the massive fires that we've been seeing in recent history. Many of these fires have been happening because they've been started just by human error, as we'll see when we start to talk about a few of them later on. Additionally, there are some gaps in the data because most of the research is focusing on how on the damage to an environment in the immediate area and not when it's washed downstream later on. I still have no idea how to work this.
It's okay. I can like stand.
Okay, so why are we focusing on California here? The graph you're seeing is the increase in large fires in California. The red line there is a rolling average. And by large fires, we're talking about at least 10,000 acres. For context, Manhattan is about 14,600 acres. So every one of these large fires is taking down at least 70% of the island of Manhattan. All but 2 of the 20 largest fires in California's history have happened since the year 2000, and 10 of the 20 largest happened in 2020 and 2021 alone. The extent of these fires is to the point where in 2020, 4% of California experienced a wildfire. That accounts for about 275 islands of Manhattan burning in just 1 year. 5 out of the 6 of those fires happened within 75 kilometers or just under 50 miles from the coast. That feeds into California being a mountainous terrain, having a lot of streams that can wash the leftover, the effluent from that fire, to coastal regions where it can do a lot of damage. Lastly, we looked at a recent meta-analysis of the state of the after effect of fires. And they noted that it was largely just a study on how California is doing things, because that is where the vast majority of the research is being done.
Oh, you touched it, sorry.
Okay, so this is a workflow showing how we're able to make our observations. Oh, I forgot, yes, it's here. So you want to start out with visualizing the fire event of interest. So we downloaded shapefiles, loaded them into QGIS and Google Earth Engine. And then we created relevant codes to see satellite images within, like, clipped to those fire regions. And next step, you want to map out the water bodies that flow out of the fire region into estuaries, into the ocean, to see, how, because that's the whole point, to see how it affects the water. And then next, you want to find in situ data in stations that collect data along that flow route that you've mapped out. There's a multitude of reliable sources, a lot of governmental sources, federal, state level, local level. So there's a lot to sift through. And some examples of parameters you want to look at are precipitation data, different types of water quality data, and nutrient data, et cetera. And then next step is organize and visualize your in situ data. So you have to create charts and graphs of relevant data to make observations. And I put relevant in there because you might find that, it's kind of disappointing when it happens, but you might be like, oh, there's a station right here, right in the flow of where I need to look at. Oh, but it only has data from the 1980s, so you have to like sift through things, X things out, look, if the state doesn't have something, see if the federal has something, different agencies, all that. So that's a whole process. And that also might influence, because again, this is a flow diagram, but it's dynamic, because as you're finding data, you might find that, oh, actually in this region where a fire I wanted to look at is, there's some data, but not that much. But in this region over here, there's a lot of data. So let me look at a fire over here, see what I could do there. So it's not just a precise flow, but this is a general outline. And then getting back to it, you want to use the in situ findings to fine tune your satellite image searches. So for example, you might have data about turbidity and see that, okay, it was high turbidity levels in June of 2023 or something. So then you can toggle your code that you're using to look at Sentinel-2 data, for example, and go to that month and see a plume, for example, maybe. And also vice versa. You might play around with some dates using the codes to look at different satellite images and see like, oh, there's a plume here. Let me see what what in situ data matches up with that. So it goes back and forth. And then, in the end, that's, how we're able to draw conclusions based on comparing in situ data with satellite imagery from various satellites. And now Kevin will go into the satellites that we used for this project.
So satellites are part of remote sensing. We're able to use multi-million-dollar devices that are up in the world or in orbits able to observe and measure things from a distance without disturbing or touching the intervening medium, unlike in situ data. We're able to look far away and not touch the area, and from that we're able to basically take all this data. Enables to observe and measure things on a spatial, spectral, and temporal scales that otherwise would not be possible without human eyes. So one of my satellites, we're able to play a crucial role in monitoring, managing, and mitigating the impacts of wildfires. We're able to observe it from a far away distance. We're able to look at this from a real-time observation and able to do analysis and long-term assessments about it. From the satellites, we're able to look at before the fires and after the fires to see what has changed and what was changed afterwards from the fire. And from this, we can have early detection and we can see, and basically we can look at it from after the fire quickly as soon as possible. And most of the data, since we're able to fund this through NASA and government agencies from our taxpayer dollars are publicly available and can be accessed to free programs. Programs that we're using is Google Earth Engine. And you can also look at it online if you want to do it. Okay. So this is one of the first satellites that we're using. This is Sentinel-2. It's a compilation of two satellites, but there's a third satellite too. But for now, we're using A and B. These are two identical satellites. It's a constellation, and they're orbiting together at in a sun thickness orbit, which means it's following the same orbit as the sun, and it gets to one revolution every 365 days. First satellite, Sentinel-2A, was launched in 2015, and the second satellite was launched in 2017. Each of the satellites carries instruments, or all the satellites in general carries instruments, and this specific satellite for Sentinel carries a multispectral instrument, has 13 spectral bands, and a band is satellite bands refer to specific portions of electromagnetic spectrum that satellite sensors are able to detect and measure. These bands are able to capture different types of energy, which is visible light, UV radiation, infrared, and microwave. And from that, we're able to collect this data, and the satellites are able to collect this data, and we're able to visualize data. The swaths width are the swath base is 290 kilometers. It's able to see, it's basically the amount of area it can take for every time. The spatial resolutions are amount of it's the amount of quality of details in data. So the smaller the number is, the more finer details the satellite is able to capture. But if you want to, usually sometimes you have a resolution of 100 meters, so allows you to have like a wide visualization. For the Sentinel-2, we're able to use it for land and vegetation monitoring, especially with NDVI and NVR, which is a normalized burn ratio and normalized difference vegetation index. We're also able to use it for water quality monitoring and land cover classifications. This is Landsat 8. This satellite was launched in 2013. This is collaborated between NASA and the United States Geological Survey. This satellite is able to carry two instruments, which is the operational land imager. This one has 9 spectral bands, and the first 8 of the bands are in 30-meter resolutions, and one of the bands in band 8 is 15-meter resolutions. It also carries a thermal infrared sensor, which is 2 infrared bands in 100-meter resolutions. This one has a swath width of 185 kilometers. And this one allows us to provide seasonal coverage of the global landmass. We're using the satellite because Sentinel-2 was launched in 2017, sometimes we have dates of the fires that are before that, so we're using Landsat 8 for this. This allows us to do land use cover and land cover mapping. We'll also use it for water quality monitoring and NDVI and NVR calculations. So this is the instrument. Like I said, the satellites are the ones that carry the instruments. This is one of the instruments that is on 2 satellites, which is the Terra satellite and the Aqua satellites. This instrument allows us to look at 36 spectral bands, and it's a passive sensor, and it's like I said, it's on the Terra and Aqua satellites. This one's these two satellites are also synchronizing, but we're able to use both of them together so we cover more land imaging. So this one, it measures the reflected sunlight and emitted thermal radiation. It allows us to detect fire, vegetation health, and also land surface temperature. We're also using it to calculate evapotranspiration, which is basically evaporation and transpiration of the plants in general to see, and basically combination of both. This one has a spatial resolution of 500 meters and a swath width of 2,330 kilometers. So it is able to cover a huge amount of land. These are both the satellites, that's Aqua and that's Terra. So with all these satellites, we're able to use a program called ORCA, which is the Optical Reef and Coastal Area Assessment Tool. This is our main tool that we're using to basically detect the plumes and everything of the indicators that we're trying to look for. This is for this area that you can see right here. This is supposed to be for the Bobcat fire. This is the area of Long Beach, California. You can see over there, these two beaches are special because from the Bobcat fire, it affected the San Gabriel Forest and the Los Angeles River. The Los Angeles River is on the one on the left, and right next to the Seal Beach is usually where the San Gabriel River is. We're able to look after a wildfire, we're able to see if there are effects of water quality changing, and from that, we're able to have a visualization of what it looks like. So right now you can see this is CDOM, which is color dissolved organic matter. This is all the dissolved particles that you can see after wildfire, and from the program we're able to have a visualization of it. So there are indicators that are basically, the indicators are measurable variables or metrics used to assess, monitor, and understand the state of change of system, condition, or process. These are indicators of the satellites are looking, especially with the ORCA program. First is CDOM, which is color dissolved organic matter. These determines the elevated levels of CDOM are indicating of runoff of organic matter from bird areas and water bodies, especially if you have if you think of older burned particles and vegetation that's been destroyed. These are they run off into the rivers and go out. And also when you have these vegetations are able to absorb the rain runoff, and since the vegetation is destroyed, it's unable to absorb that anymore. So most of the time you're going to have a lot of dissolved particulates, and from that you're going to see elevated levels, and we're able to observe this through UV visible light. There's also chlorophyll, which is a concentration of phytoplankton in the water. You're able to see a lot of organics, and we're thinking that, well, it's been thought that since there's higher nutrient dynamics from the ash, debris, and chemical runoffs, you're going to have higher levels of chlorophyll A. So this is what the satellites are trying to look at. This is turbidity, which is basically cloudiness of water. And since there's going to be a lot of soil erosion and ash runoff from burned areas, we're going to assume that the water is going to be more cloudy, and this will affect water quality and aquatic life too, because if the water is more cloudy, then it's going to be harder to treat the water for drinking, and also aquatic life requires clear water because it's for visibility, and it also can affect how the way the aquatic life is living. So we're able to detect this from able to see how much light is penetrating the water and how much it scatters and reflects. And the last one is total chloroforms, E. coli, fecal chloroforms. So we're assuming that from wildfires, we're going to have a lot of fecal bacteria that's going to be running off into the oceans and to the coastal areas. So we're able to, the satellites are able to capture this. So from the indices, the spectral indices are a mathematical combination of reflectance values from two or more spectral bands. We're able to have equations from this. So from having the near infrared subtracted from the red band and divided from the near infrared plus the red band, we're able to determine the vegetation health. This is a normalized difference vegetation index. So we're able to from the NDVI values, if you have like a high NDVI value, that means you're seeing the vegetation is normally healthy. And we're able to see if after the fire, if the NDVI values are generally lower, then vegetation of that of the area is has been affected and has been basically destroyed. We're able to just calculate NDVI using Landsat 8 and Sentinel-2. But this is also a normalized burn ratio. So we're able to have a measurement of the burn severity, which means how much of the fire has affected the area. And usually healthy vegetation has a high near infrared because chlorophyll is able to reflect green waves, and low short wave infrared reflectance to do water absorption and health vegetation. From this, yeah, we were able to have a burn area mapping and a burn severity mapping. And this is also from Landsat 8 and Sentinel-2 that we're using.
Okay, and after the satellite, we're getting to some of the in situ data showing what Kevin was just talking about. So the ash, the dry soil, and charred landscape left after a fire is known as a wildfire burn scar. It can be as hydrophobic as concrete. And so when we look at the lack of vegetation and the wildfire burn scar, that's when we see the runoff that Kevin was talking about, because one study showed a 66% decrease in water infiltration after a fire, and it also showed an 800% increase in stream flow from a burn area during the next rainy season. These scars take 2 to 3 years to heal, so you see lessened infiltration for several years, which leaves them more vulnerable to future fires just because the soil will be drier. So here, what you're looking at is a correlation between, we took in situ data from USGS for stream flow within the Woolsey, Bobcat, and Soberones burn areas. Secondly, we took precipitation data from NOAA and each of the hydrologic units within those burn areas. We filtered out incomplete information and then calculated the correlation coefficient between precipitation and stream flow. You see 3 of these say managed. We looked into that and we saw that it was just downstream from a dam. So it wasn't going to follow standard hydrologic processes because humans were interrupting it. But from these other 5, we saw that prior to the fire, there was a 0.61 correlation coefficient between precipitation and stream flow. And after the fire, it had jumped to 0.79 on average, indicating that there was much more runoff occurring. And then here, when we looked at some USGS data, on the left, you see 2 rainy seasons discharged between streams. The first one you see peaks out at around 1,500 cubic feet per second as a mean. And then after the fire, you see the peak is near 3 times as high, going along with the rain just splashing right off the surface instead of soaking into the ground. And that second one, it's suspended sediment discharge. Once again, you look at before the rainy season, there's hardly any suspended sediment being discharged, maybe a peak at like at 500. But if you look at after the rainy season, oh, and I forgot to mention, this is from the Soberones fire. And so the fire occurred from July to October of 2016. So if you look after that fire, the suspended sediment discharge goes up to about 40 times as high peak as it was ahead of time. And so all of those materials that Kevin was talking about being washed downstream were in the river, ready to get sent and have the effects.
So yeah, we have mentioned a few times the names of our fires, but here is the visualizations of all 5 of them. So we have the county fire, which is the magenta one up there. It took place in 2018, and it part of it overlaps with the Hennessy fire that took place in 2020. That was actually one fire that then combined with many other fires to make up the what's it called, lightning
LNU complex.
the LNU complex. And these were this fire was started by lightning. Anyway. And the blue one, yes, is the Sobranas fire, and then we have the Woolsey fire, which is in yellow, and the green one is the Bobcat fire. So we showed one of the plumes from after the Bobcat fire, and then Josh showed some nice statistics about the Sobranas fire. And now we're going to get into a little bit more of a case study of the 2018 county fire. Let's see. Okay. 2018 county fire. So the start date was May 29th, 2018, and the end date was June 10th, 2018. It's an unknown cause. A lot of them are. And it's like a medium-sized fire. It burned, I mean, but it's still huge. It burned almost 90,000 acres. So these are some images using the Sentinel-2 satellite that we talked about earlier. So this is June 2017. Oh, sorry. And just before we get into it, the light colors are meaning that there's dense vegetation there, and dark colors mean that there's very little vegetation there. So in June 2017, a year before the fire, we see that there's more dense vegetation in the middle. There's some, less around the edges. And then April 2018, right before the fire happens, everything grew back. It looks super bright. And then unfortunately, July 2018, which is a month after the fire, we see it basically all gone. Very dark image. And then looking at the recovery over the next 6 years, you actually see that it still hasn't returned to that dense vegetation that we saw. I know that Josh mentioned that fire recovery times are like 2 to 3 years, but we're seeing like it can be longer, especially like how we were saying, we know that these intense fire seasons happen every single year. It's kind of like they don't have like much of a chance, and these things compound. And also just really quickly, we also applied a color palette. So green represents really, dense vegetation. Red is super burn, no vegetation. Just because it helps a bit with visualization. So just scrolling through these really quickly, and you can see it still stays pretty orange, pretty yellow. It doesn't really return to green. So now getting into the water quality effects. So yeah, again, we're looking at the yellow fire. The Hennessy is the red fire, but they're just on the same map now. And then the green represents the bodies of water that make up the San Francisco Bay Area. And the lake that you're seeing right in the middle of the fires is Lake Berryessa. It's a dammed lake, so that's the Monticello Dam. It's one of the, I saw an article that called it one of the most like well-managed dams in the country. So it's very well managed. It's important for all the agriculture that happens in California for this water to be managed. But there are scheduled releases of it, and I found data of Lake Berryessa's like reservoir storage, and it's very systematic. What I've seen, like every spring, there's always just like every month, like a 30,000 acre feet, 30,000 acre feet released from it, and then it builds up again in the winter, and then it's released. So again, this fire happened in May. So as these releases are happening, we expect to see plumes coming out into where it goes, the Putah Creek. And then, so it flows east, and then it meets the Prospect Slough, and then it enters the Sacramento River, which then flows back westward a bit into the bays, specifically into Suisun Bay, but they're all connected. Suisun Bay, and then Grizzly Bay, and then San Pablo Bay, San Francisco Bay, then the ocean. So these are some stations where we were able to find data for 2018 for the fire year, and the year before, the year afters, to the years after, to see the effects. So as you can see, we have a lot of like we were really able to map out like what's going on in these water bodies. And the green, oh, I guess let me just go to the next slide. So the stations that are really along the river path are USGS stations. We found discharge data and really good nitrate and orthophosphate data. And that data is really important because nitrogen and phosphorus levels generally increase when there's a lot of things being burned and then they flow. What is that? Yeah, or it's part of the runoff, organic runoff. And then, so yeah, just going back here in the light blue, we have some data from the Department of Water Resources, from the California Data Exchange Center. We have discharge data, chlorophyll A, turbidity, dissolved oxygen, pH. And then you can see over here, the dark blue is National Oceanic and Atmospheric Administration, NOAA data, where we have a lot more. We have ammonium data as well. And let's keep going. Okay, so now I'm about to zoom into this area that I've circled in red right here. So this is taking a look at it. Again, we have the Sacramento River coming into Suisun Bay. And now get ready, it's disgusting. There's plumes. So the true color plume that's just optical, that's what it looks like. You can see that it's brown. And then let's go into, so yeah, then also CDOM, turbidity. The light blue means that there's high turbidity. Dark blue is just like low turbidity, normal levels. So now let's zoom into the chlorophyll A. Oh, sorry, yeah, and this is from Sentinel-2 surface reflectance mosaic images of directly after the fire. So remember, the fire ended on 6:10. This is from 6:10 to 6:25. And the reason why it's a mosaic is because it's kind of hard to get like a really good one snapshot like from one day, because it might be cloudy or any other conditions. So you take a little bit of a time frame, you mask out the clouds, and you get nice images like you see here. And the reason why it looks weird is because there's islands there on the side, by the way. Okay. And then let's look at the chlorophyll A data. So so having high chlorophyll A, like you're seeing like this very bright green, means that there is an algal bloom present. And looking at the nitrate levels and orthophosphate levels for that time, it corresponds with that event happening. So as you can see, going into June, in June, there's a spike, and then we see an algal bloom, and then there's a dip, because then all the algae has absorbed all that nutrients and taken it away back from the water. So that's what we see. So that's like part of telling a story with the satellite data and the in situ data. And then it tells a story of just like in general how the fire has caused this, because decreased vegetation and higher soil temperatures combined with decomposition of ash and charged materials leads to an increased presence of not only more nitrate and orthophosphate, but more soluble, because the soil chemistry is changed so that these two materials are more easily dissolvable in water. So it's just it's a big, just, it's like a bad situation. I'm sorry. And yeah, which causes the algal blooms. So in conclusion, what are some of the effects of wildfires on coastal water quality? We see increased sediment, which leads to higher turbidity, nutrient runoff, which leads to algal blooms, which both lead to other effects such as decreased dissolved oxygen, which we also have data showing. Yes, and then how can in situ data and satellite imagery be used in tandem to tell a story? They fill each other's gaps, and when they are both present, they reinforce what each other show to just make stronger conclusions. And the filling each other's gaps part is like, for example, at this at this station over here where we've started, for example, there wasn't CDOM measurements taken there, but we can see what's going on with CDOM by the satellite imagery. So that's just what I mean by that. And then satellite images help with the communication of in situ data, because you can look at charts, you can look at bar graphs, you can look at line graphs, you can be like, oh, okay, yeah, I kind of see what's going on. But I feel like it's very impactful when you see these bright colors lighting up in the water. It's like it sticks with you, and it just helps with science communication, which is such an important part of science. So thank you, everybody. And we also just particularly would like to thank Professor, our advisor, and we would like to thank, we would like to thank another advisor of ours, Erica Podest from the Jet Propulsion Laboratory at NASA. What did you say?
Yeah, NASA president. Yeah.
Oh, yeah, at NASA. And also a former student here, Reem Hunaini. She was very helpful in like helping us figure out coding stuff in the beginning. Yeah, thank you, everybody.
Welcome. We are Abby, David, and Ezra. We're going to be presenting on creating a comprehensive program for post-consumer textiles in New York. We're passing around a visual aid as well. This is just our little 2-pager that has information about what we're going to be talking about.
To click into.
Whoa, okay. Great. Little about us first. I'm Abby. My background is as a garment worker and a textile artist. And besides getting my master's in sustainability, I also teach Skillshare classes like embroidery and mending around the city.
Yeah, I'm David. I work in environmental education, also background in communication. Oh, sorry. I'm David. Hi, everybody. I have a background in environmental education and communications. And then Ezra.
Yes. In addition to being a master's grad student, I'm a resident researcher at Little Manila Queens Bayanihan Arts. It's an arts collective based in Queens, and I currently co-implementing a research regarding waste colonialism and textile waste.
A little agenda of what we're going to be going over in the next 40-ish minutes. We're going to start with the context and the scope of the project. I'm going to be framing out the problem and why we should care. We're going to evaluate some current strategies, talk some policies. We'll go through our research and our findings on our research, and then go through our policy recommendations, and then be all good. So starting with the context and the scope of this problem, the fashion industry is massive. It's $1.79 trillion, which is huge. And despite New York being one of the big 4 major fashion cities in the world, we have no comprehensive solution for dealing with the waste that the fashion industry creates. So that is what we are setting out to do, is assessing the problem and finding solutions. So I'm going to start with framing the problem. I'm going to talk about it in a scope of 3 categories, which is environmental, social, and economic. But before I can get there, I want to zoom all the way out and talk about fabric itself. In 2023 alone, the world created 124 million tons of new fabric. What happens to that fabric? This is a basic flow of how it goes from clothing to scrap and manufacture, bought by consumers, all the way through donation centers, and kind of the end goal is always a landfill or incineration. A little deeper into that, there is another option that wasn't listed in that flow chart, which it is reuse and recycle, but only about 18% of all of the fabric that's created is recycled or reused. Everything else is landfilled or incinerated. So we talk about all of this fabric going into landfills. Well, what is all of this fabric? And according to Textile Exchange, about 66.2% of all the fabric created was synthetics, smaller percent being plant fibers like cotton. And there's some blends, and that tiny little sliver in there is actually animal fibers, which has really fallen out of popularity because of how easily accessible and cheap synthetics are to replace them. These are some examples of the natural synthetic and blend fibers that you might find. And if you want to play a little game with us, you can scan our QR code and check out the side seam of your shirt. There should be a little tag in there. Mine is huge. If you don't have one, it could be in your collar. You may need some help from your neighbor. If you want to scan the QR code and put in what you're wearing today, if you have more than 1% on your tag, just choose the higher. And at the very end, we're going to go through the results and see what everybody is wearing in the room. I'll give everybody a minute to check it out. This is something that you maybe have been wearing your whole life and never knew you had. Yeah. Didn't think you'd be doing this today, right? So why I wanted to talk about that and why I wanted you to see your own clothes is to bring you back into this. You are wearing these textiles right now. So I was talking about all of these fibers that we make going into landfills, what they are, these synthetic and cellulose blends. Most common among those are polyester and cotton. So I want to break down a little bit more about what those fibers are made of. Quick tutorial of how to make polyester. First, you start with extracting petroleum. Then you extrude it and break down the chemicals and end up with these PET pellets, which are then melted and pulled through these tiny holes to make threads, which are then put onto spools, and that is woven into fabrics. If you leave this room today with one thing, I would like you to know that you are wearing and/or own fabric that is made of fossil fuels. And other most popular common textile is cotton, which is pretty much the same, except it starts with the growing process. You pick all of the cotton, you bale it, it sort of gets blown out into these big webby sheets, which are then spun up into threads and then woven into fabric. Now we understand what these fibers are made of. Now we can talk about what they do in landfills. So this study is from Cornell in 2010, where they took a few fiber samples and buried them in their lab based on this ASTMD, which is a common decomposition study. And this is the results of how the carbon content of each of these fibers broke down into CO2 within 90 days. So you can see that they treated the cotton with a couple different things. That's what those different ones are, like softeners and resins, and polyester is a completely different fabric. But you can see that the cotton broke down much faster than the polyester did. And then this is just a more deep look into that. You can see what happened to the cotton within those 90 days is that it really changed form a lot, and the polyester really didn't change at all. So that sort of has two separate problems, right? We're thinking, okay, well, polyester doesn't break down as fast, but it does take up a lot of volume in a landfill, and it also sheds microplastics. Cotton, on the other hand, does break down quickly. However, the problem with that is that as it's breaking down, it's releasing CO2. So when we did some calculations, we can see that when cotton is left to its own devices in a landfill, it will emit 24 million tons of CO2 just from its biodegrading process, which is about equal to 63 million flights between New York and Miami. So that's a huge environmental problem that we aren't even thinking about when we just throw our clothes in the trash. Socially, this is impacting the world because garment workers are making 100 billion garments every year, and 85% of them are landfilled or incinerated or thrown away. All the while, 98% of them aren't even making a living wage. Also, socially, this huge, massive secondhand market in West Africa receives 15 million tons of clothing every week, and 40% of that is almost immediately trash. They also just do not have the waste infrastructure to deal with this massive influx of clothing that they're receiving. It also affected their textile trade. The textile workers lost about 75% of their workforce, and lots of people lost their jobs because they're just getting all of this secondhand clothing. Economically, $183 million worth of garments are tossed every year. And I thought this was interesting that if consumers in 1 year around the world did not buy any more clothes, as total, we could all save $460 billion. So when you're thinking about your Christmas shopping, maybe don't think about buying new clothes. And of course, economically also, the cost burden of hauling and storing and figuring out what to do with all of this textile waste is directly set onto consumers and not the industry that made the mess in the first place. Which brings us over to David to talk about what New York City is doing about our textile waste.
Yes. So in New York City, we looked at different studies from the New York City Department of Sanitation because they do have a couple of voluntary textile recycling programs. And about 92 pounds of textiles are disposed of per New York City household every year. And we see that a lot of people, even if the city is providing an opportunity to donate your clothing, that a lot of people are still just throwing it in the trash and it's still ending up in a landfill. And according to New York State Department of Environmental Conservation, approximately 1.4 billion pounds of clothing and textiles are disposed of in the state each year. So you keep extrapolating that, looking at our country as a whole, this is a huge problem. We're focusing mostly on just New York City, but you can see that it's got wide-ranging environmental, social, economic implications. So currently in New York City, as I said, the publicly funded ones, these are like the city-run programs that they're all voluntary. There's no law mandating that we recycle or reuse our used clothing. But there is Refashion NYC, Donate NYC, and Reclothe New York. Reclothe New York is a state-funded program. Refashion NYC is basically a program where you have to opt into it, and the Department of Sanitation will give you a bin to put your used clothing in, and then you notify them when it's full. They will come collect it, and then they donate it to Housing Works, which decides, depending on the state of the clothes, if it's going to get recycled or donated. Again, this is completely voluntary, though, and the participation is relatively low. Very different than the laws around recycling for metal, glass, plastic, paper, and cardboard in New York City. That's all mandatory. So you get much higher participation. And then there's kind of just a hodgepodge of different nonprofits that try to fill this void because there isn't this city, formal city mandated program. So you have all of them listed here, or some of them listed here. And then there's those specific brands that kind of go above and beyond to provide those like repair and buyback programs like Patagonia. But again, this is kind of an inadequate way to deal with this problem. And it made our research more difficult because there wasn't a clear way to measure how much clothing is actually getting recovered in New York City, because there are all these different players in the field and they're not necessarily all providing that information. And so, yeah, you can see how much is collected through the Refashion program. So 1,829.4 tons just last year. And then you can see the amount of donations. So that, again, we got that number just from the programs that the city is involved in. So like how much is going to Housing Works. And that gives you the total of 6,673.1 tons. Still very far away from those numbers that we saw before when we're talking about how many pounds are actually being thrown away in New York City. And as I said, there's no comprehensive or measurable approach. So there's a huge gap in how we understand the amount of textile waste being produced in New York City and how much is actually being reused or recovered or being sent to a landfill. And so that's why we wanted to do this project. It's part of the reason, because we want to advocate for new legislation that kind of formalizes that process in New York City. And I'll turn it over to Ezra.
Thanks, David. So there have been notable bills that were introduced to New York State legislature to manage textile waste, and one of which is the New York Fashion Act. And so that means that fashion brands and manufacturers will be mandated to map out their supply chains. That is to really make sure that the public knows and how they can be held accountable, and particularly the upstream life cycle of the clothing. That means from extraction to production to redistribution. However, it failed to become a law in June because it did not make it in time in vote. However, despite the setback, was able to garner so much support from many legislators, advocacy groups, to try once more to pass this into a law. There is a policy concept you probably have heard before. It's called extended producer responsibility. So it is an environmental policy concept that makes brands, manufacturers to be held accountable financially and or operationally for the collection, recycling, or the disposal of the products at their end of life. For example, it shifts the financial cost of waste management from municipalities like the city of New York. Currently, us New Yorkers, taxpayers, we pay for the management of the waste of the products at their end of life through our tax dollars. On the products that the brands and manufacturers sell or flood into the market in the state of New York. But with EPR, it shifts that responsibility from us to brands and manufacturers so that they pay for the management of that waste. And so, like I said, there is an EPR bill for textile that was introduced to New York in last year. As I mentioned, it's the brands and producers, before they operate their businesses in New York, they are required to sign up. And then they are required to establish a plan for an establishment of a textile collection program in the state of New York. But that still remains a bill. There's another one. You probably have heard of the French version of the EPR bill. It's been a law in France since 2007, and it's known to be really successful in standardizing the collection, the sorting, the recovery, and the recycling of textiles in France. As you see on the screen, it really increased the collection of textiles, getting that diverted from landfills into the reused recycling economy. Most recently, this year in September, California just passed an EPR law for textiles. That's the first ever EPR law for textiles in the US, and it's very promising. However, it's because it's very new, the implementation and evaluation of it is still to be determined. Okay, well, for this research, we conducted this research methods for us to identify and understand and identify the gaps in this problem. We did literature review, we did interviews with waste professionals from both the public, private, and nonprofit sectors. We did surveys and a clothing characterization, which I'll talk more about later. Do you wanna do this?
Sure, so
I already did that.
Yeah, you go.
Okay. Different sectors.
Yeah, so I'll speak to this one. So yeah, as Ezra said, we did a number of different like expert interviews from people of various parts of the textile and clothing industry. So we spoke to Haley Wilner as the community lead at Fab Scrap. Fab Scrap, they operate out of the Brooklyn Army Terminal, and they're basically they take textiles from businesses, clothing brands, and they recycle them. And then they sell some of the excess stuff in their store as well. But what's interesting is that a lot of the stuff that they're getting from brands, because they're proprietary, the clothing or whatever, if it's a handbag or something else, it's purposefully damaged so that it can't be resold. And so the only option for them is to try to recycle it. But there are also different challenges to that. Recycling things that are mostly synthetic. And, as Abby talked about, most of our textiles today are synthetics. Those are even harder to recycle. If it's mostly polyester, it often will melt in like a shredding machine, which is the most common way for textiles to be recycled. So that poses other challenges. A little easier if it's like cotton or a natural fiber. But Wilner had some really interesting things to say about how to incentivize brands to change their habits when it comes to making them more responsible for managing their what happens to their products. And she was definitely in support of the type of EPR bills that Ezra spoke about. And thinking that like we need some kind of regulation from the government to really incentivize that change. And see who's next.
Yeah. As with other fields in the waste sector and even sectors outside of waste, data is always a challenge. And so without proper sufficient data, it's very hard to implement programs and to evaluate them. And so it's even more difficult to develop incentives to improve existing programs in management of the textile waste, and also to incentivize to apply insights from existing models, like what David said earlier. Refashion NYC is a free textile collection recycling program of the city of New York, but it's the eligibility is for apartments, buildings of 10 or more units. So it's an opt-in program. It's not mandatory. And another example is that you probably have heard of eCycle NYC. It's a really good working model of EPR for electronics. Before electronic brands and manufacturers operate their businesses in the state of New York, they have to sign up for the program and pay for the collected electronics at their end of lives. And another promising technology, as an insight from one of our interviews, is that the promise of textile to textile chemical recycling, which is to break down textiles into molecular fibers and use that to manufacture new garments. But that needs investments.
And then one of our last expert interviews, I interviewed Lisa Deagle, who is head of sustainability at Verity Brand. We wanted to pull in the point of view from one of the brands themselves. She spoke about one of her biggest challenges being marketing, and to have a take back program within a store sort of brings up this idea that it's going to be ugly and that they don't really want these like donation bins messing up the aesthetics of their storefront. So that's one of the big challenges that the brands are facing with these recycling and take back programs. Surveys.
Yes. So we also conducted a number of surveys through a variety of means. One was we hosted an embroidery workshop. Abby was really the host. And then Ezra and his organization, they hosted a clothing swap in Queens. And then that was a lot. Yeah, there was more embroidery there as well. And my job was really doing the surveying for these things. And then we also interviewed a couple just like random people at laundromats, which was fun. But we got 130 responses. And these are just some of the questions that we asked. There was a variety of them. But we wanted to see who people thought should be responsible for managing textile waste in New York City. And you can see that majority of people said clothing brands and textile manufacturers, which really fits into what we agree with. But you also see that there was a significant amount who said consumers. And we think that kind of speaks to the fact that since people are already being asked to be responsible for this, it's almost like ingrained that like, oh yeah, it's on me to figure out what happens with my clothing and to do the right thing. And, I definitely understand, like, we all have a role to play, but we really think it's kind of this unfair burden on consumers to be responsible for all of this waste when clothing brands and textile manufacturers could have more of the responsibility. And then we asked, how often do you get rid of your clothing on average? Most people said every year. Some people said every season. And to Abby's point earlier, it's like, what if we went a year without buying any new clothes? The kind of environmental impact that could have would be so significant. And yet, with the rise of fast fashion, this seems to be a growing trend where our clothing seems continuously, kind of disposable, changeable, trying to keep up with the latest trends, or, get the hottest sale, whatever it might be at the time. And so we're really being encouraged to be cycling through our clothing super fast, even if the life of our clothing could last so much longer than a year. And then how do you typically get rid of your clothes? This fit with what we kind of see in the New York City landscape. Most people, if they are trying to be responsible with their clothing, they're taking it to a donation center or drop-off site. So that's, that whole list that I presented before, Goodwill, Salvation Army, Housing Works, Grow NYC has a program. So all of these different nonprofits that are around the city. And then you still see at the bottom there, some people still just throw it in the trash. And it's just interesting to think about, how many other options there are for our used clothing, but yet it's still ending up in the trash. It's still ending up in the landfill. And part of that, we think, is that there's no requirement to do anything else with it. It's totally up to you as a consumer. Yes.
Okay.
Like I mentioned earlier, we did a clothing characterization. So we partnered with an arts collective called Little Manila Queens by Anihan Arts. So we characterized the clothes that were dropped off, donated at the clothing swap in Little Manila in Queens Woodside. And so we characterized the clothes according to the brand name, brand attribution, the material makeup, and the manufacturing origin or the country where they're manufactured from. We took some photos of each of the clothing and their tags in them. And we fed them to optical character recognition, OCR, if you've heard of them, and then extract the text from the images, and then fed them to AI to help us analyze what's in those texts. And we identified the clothing attributes, and one of which is the material content or the material makeup. So we collected a total of 496 clothes, 326 or 66% of the sample. Through the technology that we used, we were able to identify the fiber makeup, which they have polyester, cotton, rayon. As I mentioned, yeah, most of the clothes in the sample had cotton fiber in them, then followed by polyester, spandex, which is a form of a fossil fuel-based fiber. But the caveat of this is that most of the sample size shows fiber blend makeup. So a piece of clothing could have like 60% cotton, 30% polyester, 10%, whatever. So that really speaks to, it's very hard for a clothing to be recycled, or even impossible to be recycled because of the fiber blend nature of the clothes. And then we identified that most of the clothes, unsurprisingly, are made in China, then Vietnam, India, Bangladesh. And so that really speaks to how big brands outsource the manufacture of clothes and production of them to countries with weaker environmental regulations and cheaper labor. And so big fashion brands, we identified Uniqlo, Gap, H&M, Old Navy, Shein, Zara. You know this, these are fast fashion brands.
So with all of this amazing data that Ezra helped us collect, I also want to take it a step further and do a little impact report on our clothing swap. So before we can talk about the impact report, we have to go for a couple of assumptions. We're all just going to pretend these things are true. The clothing that we collected has been diverted from a landfill. So we can assume that anyone who donated clothes to this clothing swap would have thrown it away, but they didn't because it got given to a friend or neighbor. We also have to assume that the landfill that they would have been thrown into is an aerobic landfill, meaning that it's open air and allows things to decompose naturally with oxygen. So I talked about earlier that big number that was equal to so many flights. This is where that came from. This is something that I had to make myself because there currently is no standard formula for this in the fashion industry. I used this Cornell study that we talked about earlier, reminding you of this chart. Basically, what we had to do is break down how much of this piece of fiber is made of carbon. And the chart helped us figure out how much of that carbon, according to the study, converts to CO2 in 90 days. Working that all together, this formula works with weight, percent of the carbon that is carbon, the percent of that transitions to CO2 over time, and then our CO2 conversion factor, which is 3.67. So just from our clothing swap alone, we collected around 50 pounds of cotton, multiplying by the percent of 44, which is how much of the carbon content of cotton is carbon. Multiplying that by about 81% of that carbon will be translated to CO2 in 90 days. Multiplying that by our CO2 conversion factor, we have about 63.3 pounds of CO2. Doing the same thing for polyester as well. Adding that together, just in one Saturday afternoon, 3 grad students saved 104.3 pounds of CO2 by diverting clothing from a landfill. Thank you. And so that seems pretty small, but it's scalable. And that's the point of doing this, is that we're not so much proving that we made this big difference, but we're proving that we can. And so if we think about that in New York City, there's about 2 million heads of household. And if each heads of household attends one clothing swap a year, knowing that we had around 100 people visit our clothing swap, in a year, we could save about 2 million pounds of CO2 just by implementing these clothing swaps and these diversion tactics from landfills.
Yes. So as I already mentioned, New York City, it mandates the recycling of certain products like metal, glass, plastic, cartons, paper and cardboard. And, you know, you can have opinions about whether it's enforced enough or whether people comply with it enough. We certainly could be doing a better job of recycling, but it is mandated, it is the law. Currently, there's no law like that for recycling textiles. People can essentially do whatever they want with it, including throwing it in the trash. And so we are basically calling on the City Council of New York City to pass a law similar to that recycling law, which was passed in 1989, and applying it to textiles to make it mandatory that it gets recycled, and also making sure that the Department of Sanitation has the authority to see or to monitor how effective that program is. But again, that's just one piece of it, because that's really like what the consumer can do. And then Ezra's going to speak to the EPR piece and like the extended producer responsibility.
Thanks, David. So to strengthen David's point, really is that we all know there are brands which try their best to manage the end of life of the products that they sell through repair or take back schemes. But there are plenty of those who continue to do business as usual. And obviously that's not fair. It's not a sustainable system. And when few ones do good and many others do bad, it leads to situations like the tragedy of the commons. And so that's why it is really important to have a tool that levels out the playing field, that is through, for example, an EPR law. So everyone fairly contributes. The brands especially should bear the main responsibility of the management, the financial and operational management of the textile waste. And because the brands, they know they're very well positioned and they're very familiar with the design of their products. So they know how to manage the end of life of those products and be able to design them into like eco-designed, clothing that would be really good to be able to reuse or recycle at the end of life.
So wrapping everything up, where do we go from here? Obviously, we are trying to implement a more granular approach to categorizing textiles, just like we did at our clothing swap, to make it easier for recyclers to understand what to do with them. Also, as I mentioned, trying to implement what we did with our clothing swap on a larger scale. As we can see, it can have a massive impact. And we want to continue serving New York City residents to understand their part in all of this. Also, continuing using the research methodology we're also using, and we want to overall promote a more circular model of textiles. These are some little sources and any questions. Also, I'll pull up the results.
We'll be presenting on the West Harlem Energy Proposal. And our team is composed of Chloe Lodge. We have Arif Asawa Vidayaku, Jeremiah Brennard, and myself, Jonathan Thompson. Chloe Lodge will take us into the structure and the contents of our presentation.
Hey everyone. So to start off, we'll be exploring New York City's Climate Mobilization Act and Local Law 97, their impact on retrofits in West Harlem, and an introduction into how the Harlem Retrofit Lab and Design Partnership, which is also known as the HRLDP, will be advancing community sustainability. Furthermore, we'll be going into the background research. We'll be talking about deep energy retrofits, financing strategies, community engagement, and the use of distributed energy resource management systems to improve energy efficiency and resilience. Based on this research conducted relevant to each department, we'll be looking further into the available data that we'll be integrating into the HRLDP. And we'll be addressing the Climate Mobilization Act and the Local Law 97 energy requirements. To conclude, we'll be reflecting on the HRLDP's milestones and we'll be providing a roadmap for future teams to build on the HRLDP's vision. We'll be highlighting the collective potential to expand sustainable development efforts in Harlem, empowering underserved communities while meeting New York City's climate targets. So, to start, cities are at the heart of the climate change challenge, responsible for over 70% of global greenhouse gas emissions. A significant portion of this comes from the building sector, making it a key area for intervention. But our urban environments face more than just emission issues. Many cities, including New York, struggle with aging infrastructure, inefficient energy systems, and growing vulnerability to climate impacts. Addressing these challenges requires bold, integrated solutions that combine energy efficiency, renewable energy adoption, and meaningful emission reductions. And by tackling these issues head on, we can create a more sustainable, resilient, and livable city for the future. And so what is a sustainable city? It is connected by transportation systems that move people and goods to their destinations in a way that is both affordable and minimizes air pollution and greenhouse gas emissions. The air is breathable, the water is drinkable, the waterways are clean, and there is healthy food in every available neighborhood. We're going to touch on Local Law 97, and this law mandates a 40% reduction in greenhouse gas emissions by 2030 and an 80% reduction by 2050. Currently, it applies to buildings larger than 25,000 square feet, setting strict emission limits that require owners to invest in retrofits to achieve their compliance. But the law is not just a regulatory challenge, it's an opportunity for sustainability, improve public health, and increase resilience against climate impacts. And by aligning the building retrofits with Local Law 97, we're accelerating the transition to a low-carbon, sustainable urban future that benefits both the environment and the people who live in these communities.
So there are socio-economic challenges and barriers to retrofit and decarbonization. So let's take a closer look at how Local Law 97 impact different types of building. On the surface, it seems like a step in the right direction that we're reducing carbon emission across New York City. But when we dig deeper, the challenges reveal themselves, especially for communities like West Harlem and other low-income communities. So on the left, high-rise luxury buildings generally have the funding and financial resources and access to advanced technologies to meet their requirements. They can afford energy retrofits without significantly impact their residents. Now, let's shift into low-income community like West Harlem. Now, we're dealing with like old building and the property owners face deep upfront costs for the retrofits. They don't have the same access to funding like the luxury buildings or technical expertise. So this kind of like is a ripple effect. To recover this investment, owner may increase the rents. And this is where it gets challenging because these higher costs could disproportionately burden low-income residents who are already struggling to meet ends meet. So it's kind of like a big paradox we need to address as part of our project. This is why our work as HRLDP is so critical. By focusing on equitable solutions, we aim to mitigate this risk while still achieving the goal of Local Law 97.
All right, so we've been hearing some acronyms, right? WHEP, HRLDP. I'm gonna dive into those a bit more for everyone. So the WHEP, the West Harlem Energy Proposal, is a team coordinated by CCNY with the goal of promoting building energy efficiency, decarbonization, community engagement, and overall a community energy system in West Harlem. It is also a response to the climate crisis and towards legislation such as Local Law 97. Now, a community energy system is going to be composed of two things. One being a microgrid, which is a small scale system that independently generates and distributes electricity. And the second form will be a virtual power plant, which is a network of devices that balance the flow of electricity across a grid. Now, that is not something that can be done overnight. So that's where this other acronym, the HRLDP, the Harlem Retrofit Lab and Design Partnership, comes into play. we are team one of this lab, this HRLDP team. We are sectioned into 4 different departments. One being architecture and energy retrofits, led by Chloe. Second, sustainable energy technologies, led by Arif. We have financial strategies and pathways of implementing these microgrids and virtual power plants from Jeremiah. And myself, I've been leading the community outreach and engagement section because it's going to take a multidisciplined approach to create a roadmap for this community energy system. And now Chloe is going to take us into some of the background research for that implementation.
Okay, so I'm going to talk a little bit about Harlem's diverse building typologies. Typically, they include pre-war, post-war, and brownstone buildings, and they each face their own unique energy inefficiencies. For pre-war buildings, we're dealing with high ceilings, large windows, and they often have poor insulation, outdated HVAC systems, and their thermally broken windows, which can lead to the high energy consumption. For post-war, although built better with better insulation and newer systems, they still struggle with the outdated HVAC systems and window air conditioning units, which impact their energy efficiency. Brownstones, whilst smaller, also suffer from inefficient heating, poor windows, and older insulation. And retrofitting these buildings can also be more challenging due to their individualized unit layouts. Across all typologies, issues like poor insulation, the aging HVAC systems, and outdated windows are contributing to this high energy demand and the carbon emissions, which makes the retrofits essential to meet New York City's emission reduction goals under Local Law 97. Buildings account for 30% of global energy consumption and 26% of total emissions. In New York City, boilers, furnaces, and hot water heaters alone contribute 40% of the city's carbon emissions. That's more than the entire emissions from electricity use citywide. And to address this, refurbishing the existing infrastructure is crucial. The retrofits, which can reduce energy consumption by at least 40%, are a key strategy for cutting these emissions. The retrofits focus on improving both the building envelope and the HVAC systems, which are critical for achieving New York City's ambitious emissions reduction goals outlined in the Climate Mobilization Act. So deep energy retrofits involve several key strategies that make the building more energy efficient. For example, upgrading the building envelope through improved insulation, air sealing, and thermal bridging reduces heat loss and improves thermal comfort. Your HVAC system upgrades, which can include heat pumps, condensing boilers, and advanced HVAC controls, can help optimize the energy use whilst ensuring your occupant comfort. And finally, retrofitting your lighting systems with energy-efficient LEDs and smart controls like occupancy sensors and daylight harvesting can also further reduce your energy consumption. And beyond this, there are many different benefits. We're improving the indoor air quality, which is enhancing the comfort and health of the occupants, whilst also increasing building durability, helping the structure withstand weather-related damage and reduces the maintenance costs. Retrofits also boost the local economy. We're creating jobs and fostering innovation within the green technologies. And lastly, these deep energy retrofits can enhance the resilience to climate change, which we're all experiencing thoroughly today, by protecting buildings from extreme weather events and ensuring more reliable energy systems.
So moving on the building typologies and some retrofit foundation. To enhance from the building foundation, energy technology is the next step to create the efficient building. So first, we look back into the traditional grid. The traditional grid works like a one-way street. Centralized power plants generate electricity, which travels to home and businesses. It's simple but not flexible, especially for renewable energy like solar and wind in terms of localized energy management. Here, virtual power plant, the one that we do research in this project, VPP change this by connecting distributed energy resources in the same neighborhood and sharing it within the communities. They also integrated with renewable sources like solar panels and even batteries. Together, they act as one virtual power plant, offering flexibility and efficiency. And in this virtual power plant, the distributed energy resource management system acts as the brain. managing energy flows in real time to balance supply, prevent overloads, and keeping the grid stable. And another thing, cybersecurity. To protect the energy data and control system, the VPP depends on robust cybersecurity measures are essential. These safeguards defend against unauthorized access and cyber threats, ensuring that the energy infrastructures operate reliably and securely. And this shift creates a smarter, more resilient grid that's ready for renewable local energy solution and the challenges of a modern energy landscape. And in here, it's just one of the examples. Let's take a look on the virtual power plants work in balancing energy between buildings. On the left, we have like building A, which has excess energy. Perhaps they also have solar panels. This energy is sent to the VPP cloud, which acts as the centralized management system powered by DERMS. The VPP cloud balance supply and demand. It's optimized energy allocation and ensure efficient distribution across the grid. On the right, you see the building B, which require additional energy. The VPP cloud sends the allocated energy to building B, meeting its demand. This interaction creates a dynamic system where energy flow efficiently, ensuring stability, reducing waste, and improving resilience in the community.
Okay, so now we've heard about what's being done. We need to now figure out how this is going to be paid for and financed. The world of funding and finance, especially the energy sector, is extremely complicated and vast. But in an attempt to make it a bit more digestible, we've divided up into public and private. Government grants, green bonds, concessional loans, tax incentives. These are some of the financing mechanisms that are publicly available. Then we have third-party financing, SPVs, tax equity, concessional loans, commercial loans. These are the private means of financing projects. And after separating the two, we realized that we should probably combine them into public-private partnerships. This will essentially act as bridging the gap. And then diving right into the financing mechanisms, we have identified some of the most relevant to our purpose for the deep energy retrofits. Looking at SPVs, special purpose vehicles, these are especially creative, and they are a means of financing that you establish an entity that is isolated from the parent company. So in essence, a company that wants to start a retrofit project can do so by establishing an SPV and having all the funding and all the risk being taken on by the special purpose vehicle, so that when the project goes ahead, hopefully all goes well, but if it doesn't, all liability falls onto the SPV. The tricky part about this is getting people to actually agree and say, we want to fund a project that all the liability lies to this special purpose vehicle. So in reality, what's done is that these parent companies will have to take on some of the risk and some of the liability to secure more traditional means of funding. Another means of avoiding risk is by taking an energy savings performance contract. This is a financial mechanism where a third-party energy service company provides energy efficiency improvements for the retrofit at no upfront cost. The cost savings from the improved energy efficiency are used to pay for the project over time. This also means that the stakeholder involved does not have to deal with the maintenance of these energy saving systems. And then the difficult part is to convince the third-party company that the retrofit can generate profit based on projected data. A better known mechanism, green bonds are a type of fixed income financial instrument. They are issued by most funding sources, both public and private, and can even be paired with SPVs, as the separate legal entity can generate its own funding through issuing its own green bonds generated by various other sources of funding. This is a great example of what is called stacked financing and should prove useful to the goals of the HRLDP. Similar to ESPCs, the energy as a service business model provides customers with an integrated package of energy-related services, such as supply, management, efficiency improvements, and renewables, without requiring them to actually own the assets. There are key differences between ESPCs and EAS business models. The most prominent one is the payment method. ESPCs are funded through guaranteed savings, whereas the ESAS model is subscription-based. Next, Jonathan will talk a bit more about community engagement.
All right. So
in engaging with the community, we've researched tons of different engagement strategies, right? And what we've come to is something called an integrated framework theory, where you make a tailor-made approach to engaging to a certain population or group by combining different strategies and different theories. Three of the main ones are up here. So first, the diffusion of innovation. So typically it is taking advantage of the momentum behind a popular idea that is influencing a population or group, or encouraging a certain behavior in that group, right? In this case, one of those ideas, not really an idea because it's law, it's Local Law 97. So compliance and regulation, following momentum behind that to encourage engagement. Second, an empowerment theory. There were a ton of terms that I'm sure most of us in this room have not heard before today. So energy literacy would involve empowering audiences in the community and in this room with a foundational understanding of those terms so that we can facilitate conversation. And third is the social capital theory. So maintaining trust, maintaining transparency, and making sure that there is no maleficence in the operations of the organization, right? We're going for overall betterment of the community. Now, my research also took me to the public health route as an environmental health and safety professional myself. Specifically, I wanted to, I researched the relationship between public health, indoor air quality, or IAQ, and gas stoves. So in America, New York homes, over 80% of homes in New York use gas stoves in their kitchens, as I'm sure many of us do. There are particular hazards associated with gas stoves emissions. So there's certain nitrous oxides that are respiratory irritants. And why that is so important in reference to Harlem is because West Harlem has one of the top 25 highest rates of childhood emergency room visits due to asthma. So if you're in a home where there are emissions coming from gas stoves and exposed to a respiratory irritant, that just further exacerbates the issue. There are also no indoor air quality regulations specific to stove emissions, so they go unchecked. So there is a public health crisis, right? Diffusion of innovation, momentum behind that awareness. The empowerment theory is educating people about that, making sure that they're aware of it, but more than a problem, highlighting a solution. So hey, electrification of gas stoves. Instead of gas stoves, electric stoves, induction stoves, appliances that don't generate these types of emissions, empowerment. And social capital, acknowledging the issues and hazards that are in the community transparently and saying, hey, our plans can help rectify this at the source, and maintaining that dialogue so that we are, as I said, transparent and trustworthy. All right. And now we're going to go into applying all of this lovely research that we've gathered over the past year.
Okay, so after thoroughly researching the literature for each relevant department, it was imperative to look at what existing data there is currently. For deep energy retrofits, we have a figure right here displayed, and it illustrates the energy use intensity, which is the EUI, for multifamily buildings across several Harlem zip codes. The EUI is measured in kBTU per square foot per year, and this is reflecting the energy consumption of buildings relative to their size. So, as we can see, for pre- and post-war building, which make up a large portion of Harlem's building stock, the average EUI is 122.19, and this is indicating a relatively high consumption. These buildings often feature the outdated heating and cooling systems and the poor insulation, and this is contributing to the higher energy demand. In comparison, buildings constructed before modern energy codes have a slightly lower EUI of 119.89, and this is showing some improvements in design and materials, but is still not meeting today's efficiency standards. Post-1980s buildings show a more significant reduction, with an average EUI of 107.42, and these buildings have benefited from the more stringent construction standards and energy performance guidelines, which has led to the better energy consumption. However, despite all these improvements, all building types are still exceeding the target EUI of 100 kBTU per square foot per year recommended by NYSERDA for sustainable energy use. And this shows the ongoing need for deep energy retrofits to bring Harlem's buildings in line with modern sustainability goals and reduce overall energy consumption. So improving Harlem's building efficiency starts with the building envelope. We're upgrading insulation in walls, attics, and the foundations with spray foam or cellulose, reducing the energy loss, whilst also air sealing around your doors, your windows, and cracks, which minimizes the airflow and energy waste. We're also addressing thermal bridging with continuous exterior insulation, which prevents the heat transfer and eliminates your cold spots. HVAC upgrades are also another strategy, replacing your outdated systems with modern hydronic heating or centralized HVAC systems will improve the efficiency. Your heat pumps and your variable refrigerant flow, which is VRF systems, will provide energy efficient heating and cooling with precise temperature control. Lighting improvements are also very crucial. Replacing your outdated bulbs with LED lighting and adding smart controls like sensors and timers will reduce energy use and maintenance cost. And collectively, these strategies will lower your energy consumption and utility cost. They will improve your indoor comfort, and they will also increase the resilience to climate impacts, which is crucial for Harlem's low-income neighborhoods. Addressing these energy inefficiencies in Harlem's buildings is complicated by also many socioeconomic challenges, particularly because the neighborhood is home to many low-income and disadvantaged communities. One of the largest barriers is the budgetary constraints. Many property owners, especially those with older, rent-controlled buildings, simply can't afford the costly energy-efficient upgrades required. The upfront costs of retrofitting may not be recoverable through the energy savings in the short term, and especially for the small property owners with limited financial resources. Affordability is another issue, as housing costs are rising in Harlem. Tenants, particularly those in rent-stabilized or subsidized housing, are lacking the financial flexibility to invest in these upgrades. Even if these upgrades are made, tenants are not always benefiting directly from the energy savings. Not everyone are responsible for every single utility cost. And it's creating a disconnect between the property owner's incentives to invest in these upgrades and also the tenant's ability to benefit. Additionally, a lack of awareness around incentives or government programs is hindering the progress. Many building owners and tenants are unaware of the resources that could help finance these energy efficient retrofits. And without the effective outreach and education, which we're going to try and do, these programs are remaining underutilized. And finally, navigating New York City's complex regulatory environment makes retrofitting even more challenging. And whilst Local Law 97 is mandating these reductions, it does not always provide significant guidance or funding to help property owners comply, particularly in older buildings. And to ease this burden, a special prescriptive path for affordable housing has been created. But it still leaves property owners in Harlem facing the challenge of rising operating costs while needing to meet the strict compliance requirements. So we're going to have a look at a quick case study conducted by the Building Energy Exchange. And our case study focuses on a 15-story multifamily residential building in Brooklyn. It was constructed in the 1950s. Like many others, this building faced challenges such as uninsulated masonry walls, aging systems, and high energy demands. And the project's goal was to retrofit it to meet the Passive House standard, which is known as the ENERPHIT standard. To achieve this, several upgrades were implemented, as we've spoken about prior. Envelope improvements, so this is including your insulation, an airtight layer, and high-performance windows were implemented. The ventilation systems were upgraded to a balanced setup with heat recovery for consistent air quality. Steam radiators and window air conditioners were replaced with a modern VRF heating and cooling system. And the domestic hot water system was replaced with a high-efficiency boiler. The results? Impressive. Heating demand was reduced by 80%, cooling by 20%. And beyond the energy savings, the retrofits improved the thermal comfort, the enhanced air quality, and it positioned the building for future electrification and resilience. And this case study just proves that deep energy retrofits, they're not only feasible, but they're transformative. And by addressing the challenges of New York City's older building stock, we can make meaningful progress toward our climate action goals, whilst also enhancing the living environment for the residents.
So more than just passive house and some stuff like insulation. One of the questions stand out is like, how do we integrate innovative solutions that are both scalable and equitable for communities? Here, let's take a look on some partnership that we did research on and have like conversation with them they provide like real world insight and to make this vision reality. Oh yeah. So our first partnership is Tempera System. They develop a cutting edge technologies like the grid modernization platform, which supports smart meters and load management. One notable success in their work in the Brightwich utility in Tennessee, they're integrating like advanced metering and real-time data system and improve outage and management system and also customer service. So for our project HRLDP, this company show us like how Derm's technology can create smarter and more reliable grids for communities like West Harlem. And the next company we have Energy, which focuses on battery storage system. Their technology is critical for stabilizing renewable energy, especially during outages. Energy storage is kind of like the key pillar for West Harlem, ensuring we have like maintain clean energy, even the grid is under stress. This align directly with our goal in resilience and efficiency. And the last one is located in Brooklyn. It's called Marcus Garvey Village Microgrid. They offer like a powerful example of community scale solution with 22 buildings, nearly 500 kilowatts of solar PV. It's provide energy independence during outages and cut costs for the residents. Also, this project benefit from 400,000 in NYSERDA incentive, highlighting how strategic funding can amplify impact. Like for West Harlem, this is like a blueprint can leverage for communities and can address energy equity and climate resilience. So overall, this example from technical stuff and also architecture stuff isn't just theoretical, but they show us like a practical proven methods for integrating technologies, storage, and community-focused initiative in our energy plan.
So we earlier spoke about the financing mechanisms that are available to us. So now we're going to dive a bit into the program providers that will be able to, make this happen through their funding sources. So Arif mentioned NYSERDA in the Marcus gave case study, which leads us to NYSERDA is involved with many of these retrofit projects. They are a public benefit corporation focused on advancing energy efficiency within New York. They also offer affordable housing adjacent programs like the multifamily energy and energy efficiency programs geared towards the projects that the HRLDP would be involved in within West Harlem, especially. Often in collaboration with NYSERDA is a company called NYSIC. It's a nonprofit organization focused on promoting energy efficiency, provides upfront capital for energy-related projects, especially in the multifamily sector, offers various financial solutions, including loans that cover up to 90 to 100% of a project. Their key products include property assessed clean energy loans, energy pre-development loans, and incentive bridge loans. Another public resource that is more traditional is New York Green Bank. They provide similar products to NYSIC, but their loan structure is a bit more traditional and requires more stringent conditions to be met in order to provide funding. After speaking directly with representatives from New York Green Bank, it was discovered that to make the limit or to get them involved in a project, they have a $4 million limit, which cuts out the majority of the people that we want to address within West Harlem. So luckily, they provide funding to other institutions as well, like Carver Bank, and their limit is much lower at 2 million, which allows us to provide that to our more lower tier West Harlem stakeholders. Incentive programs are especially useful when trying to incorporate stacked financing, which I mentioned earlier. Con Edison, they provide many such incentive programs, and ultimately the benefits of these programs are shared between the company Con Ed, the stakeholder, and the community members. Lastly, we have the largest municipal housing agency in the US, HPD. They are involved in affordable housing construction, rehabilitation, and preservation. And then they engage in initiatives to improve existing housing quality and availability for low and moderate income residents. This is especially relevant to West Harlem. They provide funding and technical assistance for energy efficiency improvements, like through various programs. Interestingly, the NYC Housing Authority is in possession of the majority of property within West Harlem, based off the research that we conducted ourselves. There are some major corporations on this graph that you see. And while this is interesting, it is important to note that it doesn't tell the entire full picture. These groups are so big that they're able to call upon their own resources to find the best way for them as individuals to achieve energy efficiency and compliance. The HRLDP will be the resource used by the many stakeholders that aren't represented on this graph, as they might not have the resources available to achieve energy efficiency and compliance. This led us to the development of a finance model. So first, within this model, we identify the stakeholder. In most cases, it would be the building owner in direct contact with the HRLDP. We then further refine the financial and building circumstances surrounding the stakeholder, asking questions like, what kind of building are we working with, and what is the owners or the stakeholders' financial circumstances. Our funding resources are then divided into three main categories. No cost, referring to government grants and no-cost funding. Green loans, referring to the products provided by organizations like I mentioned earlier, NYSEG and NY Green Bank, that require liability and have more traditional interest rates. And then lastly, private entities that provide more private means of funding. This is something that will be explored in further detail by the following team, especially since all the financing mechanisms have been laid out. And now we have to identify actual providers. From these categories, we can identify the eligibility of a stakeholder pertaining to the program provided by the funding source. And then, for example, if a building has or proposes rent-controlled units, the model suggests approaching a company or organization like HDP. Then based on that, the model would suggest which program would fit best. In this case, the Capital Partnership for Affordable Renovation. And on that note, Jonathan will now talk a bit more about community partnerships.
So, tasked with the objective of compiling all this information about the technologies we're using, the financial pathways, other items of engagement, and creating the beginnings of a coalition that can work with us to help develop these ideas even further, to help implement these ideas so there's something tangible and physical in front of us, right? So some of our early community partners include the JMAX Bond Center for Urban Futures. They were instrumental in developing engagement strategies, which I'll go into briefly. Silicon Harlem, who we actually had an event with this past Wednesday night. It was awesome. It was our first time being in front of the public and exchanging ideas and pulling all this information in front of people, and talk about that more too. It was real fun. Also, we have the Brooklyn Virtual Power Plant, or the Brooklyn VPP. They're doing very similar work to us, just in Brooklyn. So there are different challenges that they have, public health-wise, also regulatory. However, the goal lines up with ours, and we've exchanged tons of information with them. And then two partners all the way in California, right? What does California have to do with Harlem? Why are they included in this? So the Energy Democracy Project and People Power Solar deal with a solar-powered cooperative, right? So that's a community-led group generating their own electricity and governing it on their own. And we have a lot to learn from them because we would like to implement similar practices right here in Harlem. An Energy Democracy Project teaches people how to facilitate discussion, energy literacy, job creation, and also how to decentralize a bit from electrical systems. And we're not quite there yet, but there's still a lot of resources of value in that exchange. So back to the development of engagement strategies. The Bond Center spoke with us and gave us 4 prompts. So what do we know about groups currently working in Harlem? So just found out recently that the environmental justice organization REACT that is based in Harlem received a community change grant from the EPA. So with the intention of building programs towards energy literacy, the intention of advocating and implementing policies in the realm of environmental justice. They actually have a policy for indoor air quality regulations that's at the New York City Council level right now. And it's important that we know that because that's another potential partner. What do we need to discover? That's kind of a weird question because it's like, how do you know what you don't know, right? But that's the whole point of engaging with community, getting in front of people and really welcoming that exchange, whether it's criticism or new perspectives. And what do you want from your community partners, right? Near term, integration into your networks. We want to apply all this research and other applications to the community we're trying to work in. Long term, keep integrating us, keep working with us, keep introducing us to your partners. Let's expand the network and be an actual system. And niche audiences that our team at the HRLDP are engaging with. So there is the public health indoor air quality crisis. We're engaging with renting tenants and parents that have young children that are more susceptible to those emissions. We're engaging with building owners to explain potential energy savings costs for their building if they implement retrofit strategies, as Chloe spoke about. All right, so the very fun part, right? We love games. Games are fun. They're supposed to be fun, at least. Let's make learning fun, right? So we've developed a way to gamify social media and energy literacy. Super exciting. I know energy is a crazy fun space. So social media, we're on LinkedIn, right? And if you can see those very tiny 3 beautiful faces, they're right here on the side of the room. And feel free to follow us so that, you know, it's not just me following them. So on LinkedIn, we would post and publish resources like you see on the right side of the screen. So this here is called a key terms from the HRLDP. The game component is redacting one of the terms, leaving the definition visible and challenging our audience on LinkedIn or wherever this is posted to define it for us in the comments. But we have to keep in mind, our audience is people in Harlem, right? Demographics in Harlem are predominantly Black and Latinx. So, estas palabras clave son esenciales para nuestro objetivo de energía, alfabetismo y energía comunidad. So these key terms are essential to our mission of energy literacy and community energy. But you can take it a step further. We said virtual power plant so many times. Who here gets the full gist of what a virtual power plant is? I'm still working on it myself, all right? All right, so virtual power plant, right? It has devices that control the flow and distribution of electricity throughout a grid. If you do not speak English, that's a lot to try to grasp. It's a lot to grasp, and I do speak English, right? So, una central eléctrica virtual tiene dispositivos para controlar la distribución y el suministro de electricidad en el microgrid. So, it has devices that control the distribution and flow of electricity in a microgrid. So when we speak about engagement, it's not like the least we can do is tap into the communities that we're actively trying to help. We want communities to be more than just a word on the screen, want to be able to engage with people in that way. And to take it further than that, Chloe developed an incredible pamphlet on retrofit technologies. We can implement that same gamified structure with those terms in multiple languages. We don't have to stop at Spanish. We can go to Mandarin and Cantonese and expand it to all the spoken languages in the community and make all of these terms more accessible so that the entire room knows what we're talking about, so that the community that has never stepped foot in a sustainability engineering classroom is like, oh, I know what a virtual power plant is. Oh, I know what a microgrid is. I know what energy is and how it flows. And on the left of the screen is a poster that Chloe also developed. She's an amazing artist. And we presented it at a conference earlier this year. And it really details our mission. So beginning at retrofits being those new technologies that improve energy efficiency, right? We follow it down towards implementing them in a microgrid. Even further, you're electrifying the grid. And down, as Jeremiah was saying, you got to finance it. Not all of it is free, but some of it is. And lastly, to the source community, making sure that it meets people. And this is what I was speaking about a little earlier. So we were at Silicon Harlem. We got to speak on a panel there. Thank you, Michael. It was an amazing night. We were able to engage with tech professionals. We were able to engage with engineers in the space, so many disciplines in the space. And we were able to get challenged by all of our research was able to get communicated and challenged. It should be a conversation. It shouldn't be, we have all the answers. And that led to new perspective. And the key component of that is a listening session. So making sure that we're available to receive information. And there'll be another one soon. So to speak further to community engagement, just some of the general benefits that this project can give us, including energy literacy, which I've said it 1,000 times, and I hope that we understand what that means now. As I said before, it promotes empowerment, because if you understand what's being said, you can apply it. Otherwise, it's just words flying in and out. Also, gas stove electrification and IAQ. We're bettering public health in the community by implementing electrification and workforce opportunities. People have to install these retrofit technologies. That's a program these smart devices to balance those flows of electricity. So there are a lot of benefits that can come out of this program. And remember, we're just team one. There are many. All right, so and now we will begin the conclusion.
All right. So now we are walking to the last part of our presentation. I hope everyone still enjoy and stay awake. Right? Yeah, I promise it's not going to be long, 5 minutes. So yeah, there's 3 main things that and actually outcomes and based on the data I research on. The first thing is reduce energy costs. By implementing retrofits and including technology like domes, we can significantly lower energy expenses up to 30% for low-income households. This helps reduce financial stress and provide room for reinvestment in other community needs. The next one is also, lower emission. These energy efficient upgrades directly support the local law 97, cutting greenhouse gas emission up to around 40% and aligning with New York City carbon neutrality goals. And the last one, we have to strengthen community resilience, as Jonathan mentioned. Virtual power plant and upgraded infrastructures ensure reliable energy during outages. They also safeguard residents against extreme weather in winter and also air pollution, improve their quality of life.
So as Jonathan mentioned, we are one team of hopefully many, and we have outlined some next steps, and we're in coordination with the following team to ensure a proper handoff. Some of those next steps and proposals are expanding partnerships. This is a constantly evolving space. So partnerships within the retrofit domes, community and finance and just community in general is constantly evolving. So it's very important. Refine financing mechanisms. Again, just because there's a source available now doesn't mean it'll be available later down the line. New sources pop up, old ones go away. It's very important to refine that and get it as detailed and as dialed in as possible. And then we have some pilot HRLDP initiatives that we want to propose, launch a small-scale pilot program to test technologies through domes and microgrids, use data from these pilots to inform scalable retrofits. Want to, again, like Jonathan mentioned, expand on our community outreach, conduct targeted campaigns to educate the community on energy efficiency and available programs, and also to establish a digital platform, a website or an app for project updates, educational resources, and community feedback. The vision for this is to make HLB as scalable as possible as a model and to serve as a benchmark for future projects. Long-term goals for Harlem specifically is to position Harlem as a hub for clean energy innovation and community resilience. Global and national inspiration, we want this to be applied everywhere, not just here. And then, like I briefly mentioned, the development of something like a website could be very beneficial to serve as a hub for transparency,
progress and updates in community engagement, especially. Features would include something like feedback portals and energy saving tools will empower community participation. This is what we have to look forward to. So Jonathan will now close us out. So in a lot of our research, we often saw a group of subject matter experts collaborating for a vision in the community, right? Something we often saw on top of that is that this vision did not match. Something that we also saw is that this vision did not match what the community actually needed and deserved, right? Because it lacked active engagement with the community. So that's why it's such a big component to be in those rooms in Silicon Harlem, engaging with communities, speaking to people that may or may not know about microgrids, virtual power plants, and things like that, because we didn't know a year ago. So it's important for our work in team 1 of this lab and 2, 3, 4, 5, and onward to really make community and energy true in name and in practice. Not just great on a paper, not just great in a PowerPoint, but great in people's lives. And with that, if there are any interest in collaborating or any ideas you might have, we welcome it. And thank you so much for your time.
All right, thank you everyone, and welcome to our final capstone presentation today. Our project is on community-based hazard mitigation in Western Queens. I'm Mitali, and here is my team, Andrew and Nico. Under guidance of our supervisor, Catherine, we are working to enhance resilience in community districts 1 to 4, Western Queens. So I'm going to my agenda. So here I will talk you through the objectives of our project and our methodology we used, our findings, and the next step for building resilience in Western Queens. Okay. Our primary goal is to identify climate hazard developed by mitigation strategies and increasing resilience for homeowners, renters, and small businesses. And our main focus is flood-prone areas in community districts 1 to 4, which are particularly vulnerable to extreme rainfall, heat, and air quality issues. And also, we collaborated with NISM, New York City Emergency Management and Neighborhood Housing Service of Queens, NHSQ, and local community groups to gather data, provide support, and co-developed practical solutions. Okay, for methodology.
So what we did was we used different research methods to get the best results. This included talking to people all throughout different communities, specifically the communities that we focused on. We looked at different data, checking back often to make sure that we were on the right track with NISM. So we met every month with Caroline, who's our point of contact at NHSQ, and the NISM staff. The meetings helped us figure out what the project goals were. So we need to deliver the best ways to do the research, which we included different methods and approaches. So combining quantitative and qualitative data. We took surveys, focus groups, interviews with key informants, photo voice activities, and geospatial analysis. We worked together to make sure that the project focused on what the community really cared about.
Okay, so yeah, about the increasing flood risk in Western Queens faced today. So New York City community boards prepare community district needs statement each year, which outline funding priorities. For fiscal year 2025, all 4 districts in Queens highlighted heavy rainfall, flooding, and sewer overflows as critical concern. These events are becoming more frequent and severe due to climate change. In addition to flooding, the district emphasized mostly on the, preparing the extreme heat in the summer and extreme cold in the winter. Community districts 1 and 2 also noted that coastal flooding along the East River as a significant concern. And let's not forget about the affordable housing, a major priority across the city. So by connecting short-term preparedness and long-term strategies, we are trying to help residents prepare for a changing climate while reflecting their unique priorities and financial realities. Andrew?
This one, maybe?
Yeah.
Yeah, so one of the things that we did was look into oh, sorry. We looked into the building stock, and this was in part because our primary project partner, Neighborhood Housing Service of Queens, is a housing service provider. They work with people in the community to prepare to be first time homeowners. They work on sustainability of housing and have been investing a lot of time in energy upgrades and resilience programming. So we did a scan of what the housing stock was like. 74% of the buildings in these 4 districts are 1 to 4 family homes. Probably more than half of them are pre-war buildings. The next biggest percentage are post-war buildings. So they're of ages that even if there's lots of strengths to pre-war construction. I live in a pre-war building myself and love it. But the longer a building is exposed to the elements, the more that there's the impact of weather on the exterior of the building. And so this is going to make it more probably increase the needs for older buildings to have support for hazard mitigation. We also looked at, took a step back and we were doing the lit review, looked at what were some good practices in communications around hazard mitigation, around climate change more generally. Looked at a few examples of different kinds of community guides that local governments, that nonprofits have in place to engage communities, to try to come up with some tips that we could use ourselves, because part of what we were doing in this was doing research as part of our Capstone project, but also having a couple of key deliverables for NHS Queens. One was an interactive calculator that Nico's gonna talk about a little bit later. The other was a community guide, so a way for NHS Queens to get information out to members of the community, prospective program participants, in a way try to influence the way people think about hazards, about hazard mitigation, and in a sense, steer them towards NHS Queens as a potential partner in addressing their own needs. So one way we did this was by thinking about how we could visualize the geospatial data about flood hazards that New York City now has made available. Until recently, the hazard mitigation, not just in New York, but more generally, has tended to treat the past events as past events and past conditions as what would be standards for going forward. But since climate change is affecting what we can expect in terms of the average conditions, in terms of weather patterns, in terms of the kinds and nature of extreme events that we experience, frequency, intensity, this needs to be taken into account as well. And this is something that's been identified also at the federal level recently through the White House's climate resilience policy. New York City's identified in the hazard mitigation plan that we have in place. So using these visuals for the community guide, we're trying to convey something that's zooming in specifically in neighborhoods where people live. What we have in the guide is actually a separate one for each of the 4 community districts. So that's getting a way of getting people a chance to really visualize the flood risks that are in their neighborhood. We're also trying to show what could be the extent of flooding and what are some of the more extreme scenarios, so people have a sense that these hazards exist in the neighborhood, and that is over time, as science is telling us, that the likelihood of more intense and more frequent extreme storms is going to increase, that we might shift from what you see on the left to something a little more close to what you see on the right. These are other sets of maps that we made using the geospatial data. This really just is a way to show people that 1 to 4 family homes will overlap with where there are the flood risks. So it's not, initially we were trying to see whether we could actually do some sort of count of the number of homes in that would sort of be within 500 meters or 250 meters of the different areas. But weren't able to figure out, I wasn't able to figure out how to do that in GIS, so left it as this. But I think that actually works as a way of giving the general message home to people that your neighborhood is going to be affected by floods. And if you live in a 1 to 4 family home, you need to figure out what your risks are and what your options are. And then directing people to NHS Queens as the experts on how to address them in terms of the resilience for homeowners. We've included in the guide the link to the actual city maps, which people can use to put in their addresses and see exactly where you stand, where your home is in relation to the flood zones. Also, we've been putting forward information visually to describe the challenge with capacity, with sewer capacity. So that the sewers are only able to, if they're all in good working order and kept clean, they can handle maybe 1 3/4 inches of rain an hour, which is a lot less than what we got during Hurricane Ida and less than what we could expect in what's called a 10-year extreme event, not to mention a 100-year extreme event. So this isn't a way to convey to people that you can't rely on the sewers to, even if they're in good working order, to do everything we need them to do if the rain is getting worse. And then also providing some visuals and some information to help people make sense of risk over time. So explaining that a quote unquote 10-year storm means that there's a 10% probability that it will strike in any given year, which might not seem like a lot until you have a 15-year mortgage or 30-year mortgage and you're starting to add that up over time. So here having a chart to show that math, so that the longer you're in your home, the less likely it is that you're going to avoid a storm of this magnitude, and the more likely it is that you're going to need to invest in these kinds of hazard mitigation. Try to encourage people to have a longer view on protecting homes, and that over time you'll need to factor in stormwater flood risks into your decisions. Thanks. Over to Mitali.
You. Okay, so let me take you back to August 2021 when Hurricane Ida struck New York City. For many residents, it was just more than just a storm, but it was a life-altering event. In Queens, the storm brought 3.15 inches of rain per hour, far exceeding the city's sewer capacity. So the result, devastating flooding caused nearly $883 million in damage and destroyed 33,000 homes, and most tragically claimed 13 lives. You can see the picture here. Here we also get a vivid description from one of resident who said that a river swept my belongings away. So it's kind of emotional thing. This underscore actually the personal struggles and emotional impact, such as disasters on individuals and families. So Queens was disproportionately affected, with 40% of all damaged homes located there. Lower income immigrant neighborhoods bore the brunt of the destruction, exposing systematic vulnerabilities in our infrastructure and emergency preparedness. So for call to action, events like Hurricane Ida reminds us why hazard mitigation is crucial. As extreme weather becomes more frequent, our efforts must focus on reducing risk, improving preparedness, and ensuring equitable recovery for all communities. Andrew, I think you can say about the photovoltaics.
Yeah, we did. This one of the participatory, back here.
Yes.
As a participatory research activity, we did photo voice, which is where you invite volunteers to take photos of, in this case, of their experiences with hazards, as a way of having something to speak to in the focus group. And I've used this before, particularly with English language learners. In this case, it was with folks for whom English is a native language. But it was helpful, I think, also because we generated some good photos that really spoke to what people were talking about as concerns. Here, not just the presence of health concerns. People could smell that there was something bad coming up from the flooding, and this was also a way for us to get a sense of what were not just the concerns, but what were actions that people were already taking to address flooding individually within their neighborhoods and blocks, within networks that they were starting to create.
Okay. So we did a survey on the on Queens community residents. So communities' response to hazard based on their awareness, experience, and future goals. Those with hazard experience are more aware of floodplain risks, who are living in the floodplain, but a surprising 52% lack of flood insurance. some people don't know about that. So community feedback emphasized the need for emergency kits, alert systems, and targeted education for vulnerable groups like non-English speakers and the elderly. Strengthening outreach and preparedness effort is key to the enhancing resilience. And Nico will go deeper on that.
So some of the main concerns was flooding, heavy rains that were causing more frequent and severe flooding.
Overwhelming old sewer systems, which created more problems for the homeowners and renters, and that obviously led to chronic damage to homes over time, such as mold and structural damage. Extreme heat was another one. Summers are getting hotter, as we all know. Hasn't really snowed in the last 5-6 years, especially older ones. So they weren't built to handle these temperatures, and this obviously affects comfort, energy bills, and even health. Winter in general, just the extreme cold in New York, can lead to heating challenges, frozen pipes, if a garage is open, or if the boiler room doors are open, energy bills, and less efficient buildings. So coastal risks was also a big issue. As for the neighborhoods near the East River, flooding, it added another layer of worry, especially with sea levels rising. So.
Movement here. Yeah, so we identified a number of options that homeowners can take. We also have a list for renters we're going to get to. And the real message that we have here in the community guide is you have options. And these are options that range from things that are relatively low cost and some that you could even do it yourself, depending on how comfortable you are with doing home improvements. There are other projects that will cost more, that will be longer term investments, ones where you'd need to engage assistance from a contractor or from other technicians. A lot of these we might think of as sort of along the spectrum of harden, accommodate, retreat. I'm applying kind of a model that I've come across from coastal flooding to inland flooding, but in a sense that reflects some of the options here. You can try to make your home more resistant to water. You can try to move sensitive equipment that you have out of the path of potential harm from water. You can try to live with water by having a more absorbent property around your home. So these are different options that we've put together in the guide. For renters, we know that in some parts of the communities we're looking at, renters make up as much as 70% of people in the neighborhood. So we wanted to be able to speak specifically to what renters can try to do or can do, including some things that people may be able to do in their homes. Some of this will require conversations with your landlords, but there's investments you can make in terms of putting in stormwater planters that may not be the same thing as planting a tree, but something that's a little more module that a renter may be able to take care of themselves and have their landlord agree to. Also, we looked up what were some things that people could do within their communities and block associations, trying to get more bioswales, more green infrastructure, that things that in some cases you may be able to organize through a block or neighborhood association, somewhere you may need to reach out to the city to advocate for those sorts of investments. And then also know your rights, that there is a recent law that New York State has passed that requires landlords to disclose flood history to tenants. And so this is important for people to know and to especially connect that with the mapping information that New York City has available. So you can look up a property where you're looking to rent or where you're already renting. And if you have any concerns at all about past flood history, your landlord is required to disclose that to you. Over to Nico.
All right. So this is the NHS Queens Resilience Investment Calculator. It's a mouthful. That's what I called it. We were tasked to build a tool that was designed to help residents and organizations in Queens estimate the costs and potential energy savings of various resilience investments. So the calculator is tailored to address the pressing challenges posed by extreme weather conditions, such as heavy rain, flooding, extreme heat, like we mentioned earlier, while also encouraging sustainable and cost-effective solutions. So it's a lot simpler than a lot of other calculators that NHSQ has attempted to develop. So basically, we began by identifying the needs of the users. NHSQ Staff and the community members that will be using it, conversations with our points of contacts highlighted the importance of integrating a lot of different solutions. So basically, as you can see, it's pretty clear to looking at it. It's just fill in the blanks, fill in the client's name, whoever an HQ member is working with, and then the name of a representative. And here there are tabs, so category options, the price that it would cost per category, programs, and the rebate option. So I'll get into that. So a comprehensive backend spreadsheet was created to compile data on costs, savings, and technical specifications for each option. So this data set drew on industry standards, public program incentives, and local pricing information that ensured accuracy. As seen from the quotes that surround the actual calculator, this is an example that we put on the board. So weatherization is one category, solar, construction, repairs, and there was flood prevention. And per each category, there were different options. These are some various quotes that were priced out from local contractors within the districts of 1 to 4, within community districts 1 to 4. Obviously, 31,000 is not realistic in the sense of, a project that's actually going to happen, but to get the price breakdown, we needed to get full quotes. So the interface was designed without designed without a technical easy for a lot of people that aren't technically advanced to use. So right now we're actually on like calculator version, I think like 3.0 or like 4.0. It keeps updating, and it's going to keep updating as we get more prices and as we build this database. So once the user select an option, the calculator uses a lot of the information from the back end to provide an estimate, and that would be the initial cost. So as you can see, it's approximate grand total, and then after the NHSQ rep decides which rebates and which programs apply, then it goes to the total after deductions. So most of the incentive programs offered to renters and homeowners and landlords, they get deductions off of the final price. So ideally, one would go to NHSQ, and they would work with them to finalize an actual price.
In fact, I think that's what we have written in the draft guide right now. It says, here's this fantastic calculator. Go call NHSQ, set up an appointment with one of their staff, their expert staff, and they'll walk you through this. We include a list of the programs that Nico was describing. Some of these were already described, some of the NYSERDA ones, I think, in some of our previous presentations. There's one that we came across, New York State Resilient Retrofits Program, which combines both grants and low interest loans to help flood owners specifically address flood resilience. So it provides financial support for things like elevating electrical systems, getting flood resistant materials to use in your home, installing backflow valves. So these are some of the options that we list and describe very briefly in the guide. Also, there's a New York City government rain barrel giveaway program, which allows homeowners to put in some rainwater harvesting connected to their downspouts. It's a way to encourage more sustainable practices and also start getting people to think about maybe reusing water. So if you collect water when it's during heavy periods of heavy rain, you can use that again for non-potable purposes when it's not raining as much. So we've included these links. We've also included links to technical resources and support. There's a lot that New York City and New York State has been starting to come up with. One thing that we have come across a little bit, and NHS Queens was already aware of this, is to the extent that they offer additional financial support in a connection with that, a lot of them have stopped those programs. So trying to give people a sense that these are ways that you can get additional technical information. But I think our sense from both some of the survey responses and what we were gleaning from the literature more generally is that the technical side, while useful, is not usually the main obstacle, that more often it's the cost and the financing. And so wanted to focus on that in terms of what we're putting in the guide and also what NHS Queens is going to be connecting people with.
Okay. So everyone know that climate scientists already projected and predicted that New York City will face more frequent, intense, and longer heat waves in future summers. So some residents in our survey shared their experiences, highlighting how challenging it already to staying cool during the extreme heat events. This show the growing urgency to address this issue together. I remember one said that on the hot summer days in Western Queens, the streets feels like ovens. So you know now. Okay, so limited green spaces and tree covers increase exposure to an extreme heat in Western Queens. Without enough trees or parks, it's hard to escape the heat. In neighborhood like Corona and Astoria, children play on hot playground with little shade, and elderly residents struggle to find relief from the oppressive temperature. With vegetation covering less than half the citywide average, there are few trees to provide shade or cool air. So many residents they feel like it's inescapable to stay there in this long heat waves. So home without air conditioning becoming stifling, and cooling centers can fill out of reaching for families with small children and elderly members who have difficulty in traveling also. This reality reflects a broader challenge for us. A limited green space exacerbate the heat risk and in Western Queens, making it one of the most vulnerable areas in the city. But there is hope, and we are also trying to make the solutions. And I think people will also go with the solutions as well. So maybe more a matter of ensuring affordable access to AC or other cooling resources for the elderly, infants, and small children, and persons with health needs, focusing on the most vulnerable community members. We are hoping for the best for this heat waves. Okay.
So, although not everyone in Western Queens faces coastal risks, areas along the East River are vulnerable. So sea levels rise and the storm surges, and this increases risks. Parts of Astoria, Long Island City, East Elmhurst, and parts of Hunters Point are within these coastal risk zones. So the risk zones can extend several blocks, up to 3/4 of a mile, and from River's Edge, depending on the area. So even if only a small number of households are currently in the flood zone, they're expected to grow over the next 25 years. So planning ahead is key to avoiding property damage, financial losses, and safety issues during the extreme weather events. What residents should do is use tools like the New York City Flood Mapper to understand their specific risks, factor the coastal risks into any home upgrades or resiliency investments that they're planning, and stay informed about the city and state programs.
Finally, the last hazard that we're going to touch on, air quality emergencies. And we've all lived through this year, last year, citywide air quality emergencies that were the result of wildfire smoke. It's also important, I think, to remember, and something we were putting in the community guide, that air pollution has long been a problem in many parts of the city. It's a big environmental injustice issue. And one of the neighborhoods where we focus the guide, Astoria or Long Island City, actually to that area, is among the city's 10 worst neighborhoods with respect to air pollution, even not factoring in wildfire smoke. So some of what we're doing in these last few areas is providing information that could be actionable for readers of the guide. To some extent, there's some things they can do within their homes, perhaps with NHS Queens's support to address them, but also wanted to flag them as areas that may be something that could be a point for advocacy. And this was part of what when we put the project together at the very beginning, we had a little bullet there that part of what we thought the research could be useful for would be for NHS Queens to engage people within its programs and other community-based organizations in their neighborhoods in advocacy around issues that are affecting people's lives. So this would be one of them. And in the meantime, giving some tips on using potentially air filters in your home, understanding what air quality index is, how to factor that in, especially if you or other people in your household have health issues that air pollution emergencies would impact. and giving another flag for some of the energy transition work, like what Jonathan was describing with transition to electric stoves and what's the other one? I just bought it, but I'm forgetting what it's called. The inductive stove. Yeah, I've invested in an induction stove, everyone. Making those transitions to address your indoor air pollution, which is something that's inside your control, even if we can't within our day-to-day actions necessarily affect wildfire smoke coming in from other parts of the Northeast. And so we end our longer capstone paper with a few points of what could be light recommendations or opportunities that we're gleaning from the research, targeting different stakeholders. For NHS Queens, the one that's, I think, most straightforward, which is what they were looking for from us as a capstone team, was how to potentially build on their existing energy hub programs to reach a more diverse set of households, and particularly to connect energy resilience work with hazard mitigation work. So we're hopeful that the guide is one thing that can support them in doing this, and to get other resources from their funding base in order to do this kind of work. Yeah, pass it over to
And
who's doing homework.
yeah, and as for opportunities for homeowners, I guess to invest in resilience, so make improvements like installing flood barriers, reinforcing roofs, upgrading windows to withstand the extreme weather, energy efficiency, which would consider insulation upgrades, efficient heating and cooling systems, solar panels to save money and reduce environmental impact. Take advantage of all the incentives that we spoke about. Many of the programs offer financial help, and plan for the long term. So think about how climate risks will affect property values and prioritize upgrades that protect the investments. As for renters, small steps. So renters can use easy fixes like draft proofing windows or adding portable air conditioners to improve comfort and safety. Community action, so get involved in neighborhood efforts like tree planting or shared resilience projects, and advocacy, which work in tenant groups or community boards.
For city and state agencies, including NISM, can improve hazard mitigation by integrating resilience into urban planning, clarifying funds use, and addressing project delays. Simplifying systems like 311, creating a citywide sewer database, and raising awareness in service can help residents act. Also, incentives like $200 for consultations with flood advisors and better communication through diverse channels could boost participation. And key gaps include limited access for vulnerable groups, poor stakeholders cooperation, insufficient funding, and regulatory barriers. So addressing these issues can enhance resilience in Western Queens.
And finally, engaging private sector. This is one point that came up during the focus group discussion. Folks who knew of engineers, contractors, people working in tech, other streams of work, who are trying to look at solutions for flood risk. Some of these are because they're homeowners themselves, living in areas of Queens or Brooklyn that were hit by Ida, or have neighbors or friends who were hit. So I think one of the I think creative ideas that came up was to do something where you could host almost like a sharing event where different people who are working on innovations could present them in little booths. Maybe have a way to offer financial incentives or microgrants for investing in different solutions, or just an exchange of ideas and information. One of the focus group participants had been setting up his own flood sensors in the basement, and said basically when he started after Ida, he said there was no roadmap, there was no recipe. I had to just try on my own. I'd asked around and people didn't really seem like they knew any answers either. So he found other networks of individuals and homeowners that were doing the same thing. So there's also some room, I think, for the city to try to support that kind of innovation by making little grants or small resources available, or just connecting folks. To some extent, I don't know, for some of you might be tracking the Rainproof Ready New York initiative. I went to one of the community meetings that they had sometime during the spring semester. It seems like that's a bit of what's already happening through that initiative. So here's where we are in the timeline. Presentation to sustainable community. Thank you. That's all of you. After we deliver the paper and the deliverables at the end of next week, we still have one more step that we're hoping to do in January, which is a report back with NICEM. And we've committed to sharing some reflections on this process, because part of what they have written in the hazard mitigation plan is that it's for the city, but they want to have more place-based planning taking place and ways for local organizations to use the guide as a starting point. So this is a way for us to reflect on what we learned from this process, what NHS Queens learned from the process, and hopefully be able to feed this into how NICEM is supporting this work in the future, including potentially through the next Capstone team that is starting, I think, in February. And that is our presentation. Thank you, everyone.
Good afternoon, everyone.
So good afternoon. We are the last final year presentation for the day, and so we'll try to keep it as informative and fun as possible. So our team, we are the impact of solar thermal and heat pumps and energy saving in NYC residential buildings. So we are going to, our project focuses on the quantitative analysis of energy savings using these two technology and how it can, save energy in terms of your cost as well as, your carbon reduction subsequently with the use of these technology, especially in the 1 family to 4 family categories. So that's what we are focusing on, and the introduction and the research that we did for the study would be taken over by Amber, and the next quantitative analysis for this project using the simulation tools and a bunch of other tools will be taken over by me. So Amber, take care.
Hi, guys. So this first half of the presentation will discuss energy landscape of New York, New York City residential consumption patterns, a technical overview, a comparative analysis, and we'll show you our results and conclusion towards the end. So this project will investigate our conventional energy consumptional patterns, integration of technologies, and our financial models that we'll show you at the end. Solar thermal systems and heat pumps play a significant role in our energy savings and improving energy efficiency. Solar thermal systems uses thermal systems and sunlight to produce heat, and typically for domestic hot waters, heating space heating, or for the industrial process. Heat pumps transfer heat from one place to another using electricity, making them efficient for heating and cooling. So the relationship between the solar and thermal heat pumps enhances energy savings and sustainability, which is why we thought the two would be best to compare. Some of its capabilities include preheating functionalities, seasonal complementary, and cost and optimization. Thermal systems can prevent preheat and fluid used by the heat pumps, reducing the work load and electricity demand for the pumps. And then you have solar thermal systems also performing at their best in the sunny seasons, summer in particular, while heating pumps excel in the colder weather, which is why we chose New York, because it's usually mid for both. Here we have New York City our New York City residential scenario. So we believe through our research that thermal systems and heat pumps offer a transformative potential in achieving energy efficiency and sustainability in heating solutions by reducing recline on fossil fuels and acting to reduce our greenhouse gases and carbon emissions, lowering overall. And at the end of that, operational costs and advancing clean energy. Their combined use will further amplify their benefits, making them a compelling choice, which is why we're promoting it. In this bar graph, you'll see 57% of New York homes have heat in their spaces, and they're using natural gas. Despite dwindling use across the country, fuel, which is at 29%, still remains a popular option. but they're still looking towards dwindling it. 20% of New York has AC systems compound with 53% who still utilizes individual windows and wall units. And in this New York City residential scenario, we have a pie chart that shows one family detached homes, 1 to 2 family dwindlings at low density. Multifamily housing made up 60% of New York City's residential in 2018. That's where this chart is from. This chart looks at spatial characteristics, looking at a potential's front yard, backyard, sidewalks, driveways, and then comparing it to urban planning implications that will probably look at zoning laws and transportation infrastructure, and then affordability and the housing supply and demand. The fact that 60% of residential lots in New York City consist of low density just reveals the historical pattern of suburban style, pronouncing the word water. Okay, sorry about that. And challenging and addressing housing demand base essentially, and New York City's population and area and growing. Sorry. Here we have why solar, thermal, and heat pumps, why we comparing the two. So we show you the benefits. We have direct heat energy, space efficiency, increased efficiency, and cost efficiency. While also using heat pumps, we have powerful efficiency, heating, cooling, electrification, and environmental impacts. So those are the main benefits as to why we want to use it, but we understand the reluctancy of adapting and switching over. So the goal is to reach it by 2050 to have it be implicated in vast and sorry guys. Okay. So in 2050, they want to see the increase, and we think that is overbearing. So that's where main challenges and considerations come. So the initial costs, you have the upfront investments is really high. People don't really want to get into it. We have climate stability, solar thermal systems, they depend on the sunlight. So location matters greatly for this use. We have integration and complexity, design, installation is also very crucial in using it. And then other accommodations and considerations highly include accessibility and the environmental impact. And both systems require a robust recycling for waste management for it to work and succeed beyond the 2050 goal. So then materials like refrigerants, glass, metals, we're constantly keeping that in mind. But the strategies that should overcome it is policy investment, carbon pricing, frameworks. Everyone's looking to do their part in terms of technological innovations, infrastructure development, and grid modification to the supply and demand of the resilience of what they might need or might not want. And then just overall public awareness and compliance and education, constant education and updates on it. So here we have a technical overview of the chunks we use or how it would work. So we have a flat rate, which is a structure that collects and consists of a flat rate plate. It absorbs it. It's enclosed with both a transparent glass or plastic, glazing usually with insulated backing to minimize heat. And then you have an absorber plate where it backs up and exposed to sunlight, transferring the heat to fluid flowing through the pipes, as you can see in the illustration. And then in the EVAC, we uses multiple glass tubes, which have layers of glass and the vacuum between the two, which provides the installation. But the most important thing to remember about that is flat is cost efficient, it's suitable, it's moderate. And the EVAC is better for colder and climate conditions and high temperature. So moving on, here is a look into what a heat pumps look like. We have heat pumps, it brings heat from the outside into the house, and then it heats the water in the central space. The interior device transmits the heat, and outside unit absorbs it. After absorbing the heat, it evaporates, compressing it to raise temperature, and the refrigerant in the system condenses it, and the process repeats all over. So that's what the inside of it looks like. That's what you're looking at. Here, we have multiple heat pumps you can use in a single or multi-style family house. For our project, we focus mostly on mini heat pumps and multi-zone air source heat pumps. The pros is a lower cost, simpler installation, efficient for one room in particular, focused on temperature control, exact, and it's easier for retrofitting. And then multi, we look at that in terms of zone control, whole building coverage, flexible indoor units. And then cons would be mini, you can't move it. It's for one room particularly, and is at a higher cost for multi-zone if we want to install that. And that's, people kind of dial back from when you say cost. So less efficiency. Here we have our methodology of what we use. I'll just run you through the process. We looked at 4 modeling houses. Then we went to build the model in the software, applies specifications of the existing conditions. Then we chose the case to run our simulation. Then we repeated the process. And then we generated the Energy Plus results. And then we compared the results, which we'll go into further detail later on. So these are pictures of the 4 houses we looked at. Process once the residential models are identified, the energy consumption pattern and appliance are obtained through surveys, if you're wondering how we identified it. Here, if you take a second to familiarize yourself with our chart, it'll give you the data stock of what we use. I'd want you to focus on the borough. We chose Queens. It was more, suburban area where this could likely go and implement it. Starting points in New York. Look at the occupants, look at the heating equipment, cooling. Yes. And then next, we have the residential stock data assumptions, where here we use roof and R values and our quantitative analysis to assess the data from previous research. So with that being said, I'll now pass it on to my colleague and she'll go into the scenarios and the attempts. Thank you.
So to the qualitative analysis of the project, so we chose 4 buildings in the Queens, and we understood their energy usage patterns because it considers about various factors within the family. So it's like occupancy and the usage of your services, and also the family practices. So there are a lot involved, and sometimes you have to standardize few of the details to fit into your model, because not every building is same, not every home is same. So your energy is gonna vary. That's what from all these study I've understood. It's like no building is same, and it's gonna be different. And especially when it comes to modelings and simulations, when we are depending upon a software, we have to do few assumptions. So some of the assumptions we had to do is basically comes with the age of the building and the physical aspects of the building. So we had to kind of put in few assumptions about the roof insulation and then wall insulation, and few of the standardizing the doors and windows, even if it's not the ideal condition. but we took into our modeling saying that, it might be if we had these conditions, it would pose a better, results for us. So, and the indoor optimal temperature set, again, that varies to each every home, but this is something we had to, again, fix, and then we have to process it. So these are some of the aspects which we assumed for the modeling, and then how we process this. So the modeling software, which I had started with, this is Energy Plus, and which is like very complicated software where the modeling can be done with easily with your Open Studio and your SketchUp. But then as you go into the modeling, it's going to get complicated, and you need to have a basic understanding of how all the system works. So I had to go back and then understand each and every aspect of the building, which helped me with my building science class, understanding how an entire building works. So that way I was able to, even if, let's say, I get a results out with this simulations in the software, but then I was not sure whether that's the result I'm getting. So I had to go in and check, the math formulations and make sure that it comes up, somewhere. There are some aspects that's gonna be a plus and minus errors or a few things, but I was able to achieve, a balance between both. So that's how I started out. And yeah, Energy Plus was complicated, and there are like different other softwares available free and with NRL and other agencies, energy agencies, government agencies. We have this BOPT and Equest, which proved to be a lot less simpler than Energy Plus, if anyone want to try it out. So which you can see, the simulations. This is one of the pictures which I took from when I was modeling. So this is like tells you about how the external walls, which are the internal walls, and how thick the walls also. These are some of the things I adapted from the real life model, but then I had to tweak in few values. So this is the entire process which I followed. And coming to the first scenarios, like what happens with this project is, like, we take all these 4 families and then like buildings, and then we are formulating with different scenarios of technology combinations. So it's just not going to be one simple integration, but then we're trying to find out how one technology alone is making a big difference in your either utility bill, or how your energy is like saved, or what kind of difference you see. So first we started with a baseline comparison. That's your conventional energy use. So we typically, based on all these informations, just with a conventional system of natural gas for our space heating and domestic hot water, electrification for the other appliances, we understood how the model works, and then what results it comes out, it gets out. So as you see, I try to chart out the seasonal changes, and as we see, the December is for the heating loads spike where you see in the gas bill, and then you see a difference in your cooling, that is your electricity bill during your summer. So that's a general idea which we generally, your energy bill gives you. And as of some of the units constants, like as of 2024, I try to set the utility cost constant as your 1.598 for your gas cost and dollars, and electricity cost is 1.29 throughout the model. So the range to compare is easier. Yep. So as we chart out the different families and how their energy and your gas and electricity bill comes. So as you see, it's like your electricity bill is high, and then your gas bill is like towards to 1/3, and then it keeps increasing as your space increases, the occupants increases, and also the pattern of usage. So these are some of the determining factor which increases your cost. And also with respect to the gas consumption, we have 4 major things, like our store range is still, as we discussed, it's still uses gas. And then we have domestic hot water heating also used by gas in your space. So what's the different percentages each takes up? And also our laundry system for your drying takes up hot water. So we sort of trying to establish a base for us. So how much is your space heating? How much is your how much is your domestic hot water? So space heating takes up much, and the next is the domestic hot water, and then you have your gas and your, cooking and your laundry purpose. And we establish a baseline comparison for the electricity cost and the gas cost for all the 4 models. So that's our reference, and then we're going to check what the technology is making, like how much it's like changing the pattern. So second, the scenarios that we are setting up after the baseline is the solar thermal for the domestic hot water system. So what goes into this model is like factoring is like the number of occupants and the area for the building, as well as like how much hot water consumption each family is taking up. So that requires the plumbing aspect, flow, so which are all like technical aspects behind that runs for this modeling. And then we establish a base cost for this solar thermal just for your hot water system. And then we try to compare it with our base conventional source. But some of the assumptions that not assumptions, but some of the factors that goes in, like solar thermal performs with seasonal, not seasonal aspects with respect to how your sun shines out. So some days you have an overcast overcast happening and rainy seasons like we had a few days back. So what happens during this and what's the auxiliary system that you're gonna set up with? So the auxiliary system is gonna be natural gas. And for this particular scenario, and then you set up other incoming water temperature and then hot water temperature. This is like standards set by the US energy assessment. So this is the standard. And then you have something called solar fraction, which talks about the efficiency of the solar thermal. So let's say most of our, based on our climatic factor as well as the system, 75% is what is suitable for our, US climate zone, zone 3. So that's again comes into a major factor of, 75% is like met by your solar thermal, but 25% again goes to the natural gas. And then the efficiency of the system. And there is something called, solar insolation tilt factors, which are something, I read upon saying that that's important factor that goes into the modeling because it talks about the solar sun tilt and all the things. So this is the second scenario. And then I again got the energy utility bills based on just the system with an auxiliary system of natural gas. So what happens here is like you see a little shift in your electricity bill, but 25% reduction in your gas bill. So that's something that's achieved just using your domestic hot water system of like solar thermal for your hot water system. And now we are talking about like the cost. So what's this particular system alone is going to be for your building. So solar thermal takes up like smallest areas compared to solar panels, and then which has less. And then again the assumption factor is like it's just not the panel, which could be costing around $2,000 to $2,500, but the storage system and the plumbing works that goes into also is considered. So that's why you have a range of starting at a $5,000 range. So which again is calculated for the next 4 buildings and trying to understand the payback period, which is like falls around 6 to 7 years. And yeah. So we are next going to the third case, and finally we'll like compare all the results together at the end. So the third case scenario is like your heat pumps just for the space heating and cooling. So again, the modeling that goes here is like the cooling load and the heating load. That's for the annual, and then you see how much choosing your heat pump efficiency. So see, there are like 2 factors again that comes into it: the CR rating and the HSPF, which is for your heating, like cooling and your heating performance factor. So you select a heat pump which is the highest in this, and that's again cost much more when you take the maximum most efficient. So again going that into, so what happens with the scenario is like you see a higher shift in your electricity bill, and but a 50% to 70% of reduction in your gas bill. So we are taking it. And again, the costing and how much with the initial upfront cost, how much is the payback period. So those, these again, it's calculated based on an average range, because you have a higher end and a lower end. But we're trying to make sure that there's an average costing that can be put into play here. So that's something that goes into the model, important factor. So 4 scenarios like integration of solar thermal and heat pump here with an auxiliary system of when it's an overcast time, so natural gas. So we are integrating these 2 systems and then trying to see what's your electricity and your gas cost. So you see a significant decrease in your gas cost, and you see your baseline is maintained in your with this integration. So your electricity is like hasn't gone up at all, it just maintains in the baseline. So which got me thinking, so this is like another system where, you know, we are depending on natural gas. So what we can do to completely go off natural gas. So maybe the heat pump can take up the auxiliary system. So, but again, what happens is like this was done after I did all my scenarios and comparison. So this was like a side project for me to understand how this particular system is going to work. So which happened to be like, you're going to see a shift in your electricity cost, like much more higher, but you have a like negligible bill in your gas cost. So again, yeah, here is where your investment cost is going to be high, and it's going to be huge amount, even if you're going to start with a lower off range, and your payback period is going to, for a single family, it's going to be much huge. So here comes our financial feasibility, where we are going to look into our incentives provided by the federal, state, and the city, where the baseline is like 30% of like solar grant you can get for your solar system. It's again, you know, we are establishing an average which you can get from the incentives point of sight. So like as as I understand how the incentives work with the state, it's like there needs to be a lot of process before you attain the investment. So we are trying to make sure that you have an initial upfront cost, and also with a minimal incentive added to it, like how much you're attaining. Is it like in a feasible point of view? So a 30% is applied, and then we get to see the payback period getting lower to 9 to 10, which seems to be a suitable payback period understanding for investors. So finally, the comparison scenario, which we get to see as we see in the graph, like what's the best case scenario to adapt. So which proved to be the heat pump and solar thermal with an auxiliary of natural gas seems to be on below the baseline, with the other systems going a little high in the electricity cost. So that's what is proved from the project. And also the financial feasibility comparative. So with your initial cost and how much it's like reduced after you add your incentives to it for all multiple scenarios. And so with the 4 scenarios, we're trying to establish like how much in numbers all these scenarios is bringing your electricity bill down, or it's going up in terms of your gas. So as we establish again with the graph, the integration is much more ideal case which we can adapt, and then you see a significant change in your utility bills. So finally, conclusion is like the project aims about trying to promote our clean energy programs, especially when it comes to low-rise residential multifamilies, where as we saw, it's like 60% when it comes to the zoning lot. So we are also trying to make sure that, and also when it comes to the ownership model, it's much more easier when we focus on the lower, low residential buildings, and the investments wise, it's also kind of goes into the picture, like it's more feasible. So, and also we make huge impact if we start concentrating, the owners start adapting to, these technologies. And so which another factor which we didn't consider too much into our project is the retrofits, because all this is like very old buildings, almost like 50 to 80 years to the range. So if we come, put that into play, again, your initial investment cost is gonna go up, ranging from, $15,000 to $20,000 just for one building. So but it's something, which this could give an idea for the homeowners, like where we start. So which is the, how do we progress it? So what we start initially with, maybe with the retrofits, and then we go on, getting one technology or combining it together, seeing it, how it's going to affect, how it's going to affect them personally on a long term. So, and then, the resiliency. So how do we all combine it together and make sure there's a plan for how to progress it step by step in a feasible way? So that's how I think all our presentations today showed us to make sure that how these options are, how to make it all feasibly possible in the next coming years. So
my takeaway when do we start? The time to start is now. Their trajectory, looking at the research, is 5 years to now to reach that goal. And if we don't, whose fault is it? And I feel like that's what this program has taught me in all the research. Who and what are we investing in? And who, us, the what, the earth, so, thank you.
So that's our team. And yeah,
Comments,
questions.
concerns.